Hey guys, this is the first chapter of my Unity crash course. We're going to be making an adventure game. You're going to get the course introduction shortly. I'm selling this course on Udemy and my Gumroad store. If you buy on Gumroad, I get a bigger cut and you get every video in the course as a downloadable file. Please support this video by liking it and sharing it with your friends, and let's get started. If you've ever wanted to make a game but don't know how, or you are at the beginner stages of game development, or even if you are in the intermediate stages and you're in that awkward phase where you know some stuff but you're not sure how exactly to make a full game, this is the perfect course for you. We're going to go through everything from the very basics of what Unity is and what programming is to making a full game at the end of the course. I personally learned programming by making games and having fun and learning along the way, and this is how this course is structured. We're going to see some real examples of situations that you're going to be in and how to find your way around Unity and how to use the C# programming language. If you've ever been afraid of programming or you think it's too complicated or too hard, in this course we're going to see how fun it can be. You're going to see that actually if you learn a little bit of programming, you're going to unlock a lot of potential and you're going to finally be able to express all the game ideas that you have. My name is Zuhair. I run a YouTube channel called Zeus Game Dev Academy. I'm a professional indie game developer with 10 years experience with Unity and almost 15 years experience in programming, but also in 2D and 3D art. And I picked up a few game design skills and level design skills along the way. I'm going to show you how to approach game development like a professional and how to get actual results. At the end of the course, you'll gain enough confidence to make your own games and handle all the difficulties that Unity and C# will throw your way. The game that we'll be making is a top-down sort of dungeon crawler. We'll start with the basics of movement and camera management. We'll add jumping. Then we'll add coins that you can collect. Then we're going to add a few traps, from a spike trap in the ground to a spinning blades trap like you can find in most adventure games. We'll create a UI and some menus like a pause menu, a main menu, and a game over menu. Then we'll create a simple mission system where you have to collect all the coins to unlock the exit of the level. Once the exit has been unlocked, you will be able to go through the gate and go to the next level. This is a strong foundation to build upon, and you can apply the principles that we're going to see in any game project you can think of. Start today with this strong foundation. All right, see you in the course. In this lecture, we're going to install Unity. So go to the Unity website at unity.com and click the download button, then choose your operating system. We will download the Unity Hub. After you install the Unity Hub, you'll probably have to create a free account. Then you will have a window like this where you have your projects and the Unity versions that are installed. In this tutorial, we are going to use Unity 6.1. So let's go to Install Editor. Let's look for it in the official releases. This is 6.1. We need to hit install. It will ask you whether you want to install Microsoft Visual Studio. This is where we'll edit our code. It's a good idea to install it unless you want to use something else. Now all we need to do is wait for it to download the Unity version. If you're watching this course at a later date, probably there will be a new Unity version, but this almost doesn't matter because the concepts that we're going to see are probably going to be valid years from the making of this course. Okay, I'll wait for it to download and I'll edit this part out so we can continue with creating our project. Okay, Unity 6.1 has been installed. Now let's go to projects and let's create a new project by clicking on this button, new project. Now we need to choose a location for the project and let's choose the universal 3D template here and let's give our project a name. I'm going to call my project Zeus Unity Crash Course. Let's make sure that the editor version is the one we've just downloaded, 6.1, and let's hit Create Project. You need to agree to the terms of the Unity editor software, accept and continue, and this will load the Unity engine. We had to wait for Unity to create our project, and this is the interface of the Unity editor. What is a Unity project? A Unity project is made of scenes. For example, here we have sample scene. A scene, you can think of it as like a level in your game. And by the way, I'm going to simplify a lot of concepts, especially for you guys who are complete beginners to game dev and Unity. But if you are more familiar with Unity, you will know that perhaps in practice, we can make levels out of multiple scenes. But to simplify things, let's assume that a level equals a scene. You are certainly familiar with games where you have levels and you complete the first level, then you go to the second one, and so on. This is pretty much it. Here we have the project view, and here we have the files in our project. In the assets folder, we have all the files in our project. We have the scenes, and here we have our sample scene here. This is the scene that is currently loaded. We have settings, mostly the settings of the renderer. We are using the universal renderer. Here you can edit the quality settings of your game and all that good stuff. And here we have this tutorial info. Let's click on this README file. And here we can simply remove the README assets just to clean up the project. The scene is made of game objects. Here in our sample scene, we have the main camera, we have the light and the global volume. All of these are game objects. We can create a new object. So let's create a cube. Let's click on this plus button and then 3D object, cube, and this is it. So here is the scene view and this is the hierarchy view. Here we can see all the objects in our scene. Let's click on the cube and hit F. Now we can focus on it. We can rotate the view by hitting Alt and dragging the mouse while clicking the left mouse button. And we can do a lot more stuff here. So we have a lot of buttons. And in time, we're going to see what each button does. A game object is made of components. For example, here, when I click on the main camera, I can see the components of the main camera on this panel. This is called the inspector. We have a transform. Any object that's present in the scene has a transform component. This is a mandatory component that Unity adds to every game object. Then we have the camera component with some parameters. And here we have an audio listener. And down here we have the game view. When we run the game, so if I click on this button, I'm going to run the game. So Unity will compile all the scripts and all that stuff. Here we can play our game. Right now, our game is kind of lame. We just have a cube with a camera. I can change the parameters of the camera. Here we already have the main camera selected. I can change the field of view. Right now it's set at 60. I can change it to something small. You can see that the angle of the camera here is more narrow, or I can set it to a big value. So we can change the parameters of our components here. But since I'm doing these changes at playtime, so now we are at playtime. If I go out of playtime, if I stop the game, the original values of the parameters are reset. So here we are back to having the field of view set to 60. However, now we are at edit time. If I change a parameter here, it will be saved with the scene. Here we can see a little star next to the scene, which means that we have unsaved changes. If I hit Ctrl S, I'm going to save the changes. Now I said that a scene has a list of objects, but it also has more parameters. Here we can access the lighting tab through window, rendering, then lighting. By default, it's not present. So let's right click on it, close tab. If you don't have it here, you can go to window, rendering, lighting, and then you can dock it on the interface. I can click here, then drag and dock it either here or here. It's your choice. We can create some lighting settings. We have the environment tab here where we can choose the skybox material. Basically, this is the sky. If you want to change the material of the sky, we can change the environment lighting. We can increase the lighting that's coming from the sky. Let's keep it at 1. We also have other parameters like fog and environment reflections, but that's pretty much what a scene is. It's a list or a hierarchy of game objects, plus a few settings for lighting and the sky and fog, etc. Now, when we say hierarchy, we really do mean hierarchy. Let's focus on our cube by hitting F. So here, if I have this cube, let's Control D to duplicate it. Now we have 2 cubes. I just hit W on my keyboard. This has selected the move tool. So I can move the object by dragging these movement gizmos. So if you click on one of these squares, you can move the object. Here I'm moving it on the horizontal plane. When I said hierarchy, I really do mean hierarchy. You can have one object be a parent of another object. For example, here, the second cube, we can have it as a child of the first cube. So whenever the first cube moves, all its children will move with it. Okay, now let's talk about the scene view. I'm going to right click here and maximize it. In Unity, we have 3 axes. We have the Z axis represented by the blue arrow. We have the X axis represented by the red arrow, and the Y axis represented by the green arrow. The Y axis is for moving up and down, and the X and Z axis are for moving on the horizontal plane. Let's go back. Let's right click and click on maximize. Here we can change these values in the transform. For example, if I want to move my object along the X axis, I can click here on X, then drag the mouse cursor to change this value. Or I can type a specific value, for example, 2. This will move my object 2 units on the X axis. And in Unity, units are pretty much meters. So we can also say we have our object at 2 meters on the x-axis. And here we can rotate the object, let's say around the y-axis or the x-axis or the z-axis. We can also scale the object. Usually you'll want to scale an object uniformly across all the axes. So let's click on this button to constrain the proportions. Then we can change one of the values and it will change all the values. Let's recap. A Unity project is made of scenes. A scene is made of game objects and some parameters. And every game object is made of components. A word about components. Pretty much a component is a script or a code or a program. These components are provided by Unity out of the box. For example, on our cube, we have a mesh filter, a mesh renderer, a box collider. These are provided by Unity, as well as the camera component, the audio listener, and more stuff like the lighting. So here we have the directional light. We have a light component. Here we can change the color. Let's click here and choose color. And here we can change the color of the lighting. You can see that our cubes now are lit with a red color. We can also change the intensity of the light if we want it to be very intense or less intense. By the way, this directional light, you can think of it as the sun. It shines on all the objects in your scene uniformly. As I said, objects are made of components. Some are provided by Unity and some we can create ourselves. So we can create a script that will serve as a component. And in fact, most of our game logic, most of the things that will happen in our game are components that we're going to add to various game objects. We have these game objects that live in the scene, but we can also have game objects that live in the project. If we take, for example, our cube here, if we drag and drop it to our project window, here we have created a game object that lives at the level of the project. This is called a prefab, and the instance of that prefab that lives in the scene is called a prefab instance. So we can have a lot of these. Let's Control D to duplicate this prefab a bunch of times. Now if I double click on my cube prefab, now I'm in prefab mode. You can see here that I'm editing my prefab. If I change something in this prefab, let's say I add another object, let's say a sphere. Let's have it over here and let's go back. Here you can see that every instance of our prefab now has a sphere as well. Prefab stands for prefabricated game object. It's a nice way to prepare an object and create it as you want it to be with all the components that you want and then save it in the project. Then in every scene in your game, you will have an instance of that prefab on the scene, and every change you make on the prefab in your project will be reflected in every scene of your game. And this is extremely useful. Okay, let's delete these objects. I'm going to click on the first one, then shift click on the last one, then hit delete on my keyboard. Then I'm going to do the same thing for the cube here. I'm going to hit delete on my keyboard to delete it. If I right click here, then show in Explorer, this will open the operating system file browser. Make sure that you can see the file name extensions for every file that we have in our project and every folder. Unity creates a .meta file. I'm showing you this just in case it startles you a little bit. This is completely normal. It's a way for Unity to identify each file and keep track of it. So here we have the files of our project inside of the asset folder, and pretty much this is what a Unity project looks like. Here we have assets, library, logs, packages, project settings, temp, and user settings. Plus here, this is the Visual Studio project. Pretty much these are all the files that will allow us to open our project in Unity and edit it. Let's go back to the Unity editor. In the project view, you can see that we have the assets folder here, and we also have the packages. Packages are like add-ons that are added to your project without being present in the assets folder, and you can access the list of packages either here, or we can go to Window, Package Management, and Package Manager. Here we can see the packages that are in our project, and if you purchase something on the Unity Asset Store, you can see it in My Assets. Then here we have the Unity registry. These are the official packages made by Unity. Okay, this was a brief overview of the Unity editor. I showed you the most important aspects that you need to be aware of. Of course, as in any piece of software, you have a lot of buttons. Here we have a lot of controls, a lot of buttons, a lot of menus. Don't be overwhelmed by all of this. It's good to develop a kind of tunnel vision, only seeing what you want to use and ignoring the rest. And with time, you will understand what each button does. In this lecture, we're going to download some models and create a level in our game. One of my favorite sources for free models is kenny.nl. Let's go to the website, then go to Assets, then 3D. Here you have a large selection of assets. I'm going to go to the second page where the mini arena is, and we're going to use these models. You'll find the same file in the downloadable files for this course. I also have a zip file with some extra objects that I created in Blender. Let's copy both of these zip files. Then in Unity, we're going to right click on the assets folder, then show in Explorer. Now we have our file browser open. We're going to click on assets, and here we're going to create a new folder. So I'm going to create a new folder in the Windows File Explorer. Let's call it content. And let's open it, and let's create a new subfolder here as well. Let's call it models, and let's click here. And here I'm going to right click and paste my two zip files, and I'm going to unzip them. I'm going to right click here. I have 7-zip, but you can unzip them using the Windows File Explorer. It has a zip utility, or you can use WinRAR or any unzipping program you want. Okay, so I'm going to extract them here, and here it's safe to remove the zip files, so I'm going to delete them. Now we have these folders. Let's go into Kenny Mini Arena. Here we have samples, preview, and the license. By the way, all of Kenny's assets are licensed under the CC0 license, which is the public domain license. So you are pretty much free to use the assets in any project you want. Let's go to models. Here we don't need the GLB and OBJ formats. I'm going to delete these folders by hitting delete. Let's just keep the FBX folder. Here you can see the various models that have the FBX format. Now let's go back to the models folder. Here let's open my mini arena extra objects. Here I have an enemy, a coin, some details on the floor, and a spike trap. When you open this file, maybe I'll have added more objects here. Just make sure to add them all to the project. Now let's go back to Unity. As soon as the Unity editor is in focus, you can see here that it's updating the list of files. So let's go to content, then models, and here we can open the Kenny Mini Arena folder, then the models folder, then FBX. And here if I click on an object, let's go to model. Here we can see a preview of the model. So we have a block, bricks, our character here, and other objects. And here in my mini arena folder, I created a model that we will use as an enemy. I also have a coin. Kenny has this model, but with a floor square. I removed the square in case we just want to add these details. Then I have a spike trap. This is the base of the trap, and these are the spikes. Okay, we have these models. Let's move the character soldier to our scene. We can either drag and drop it from the project window to either the scene view like this or the hierarchy view. And here is our character. Let's drag and drop the floor. This is a floor square. I'm going to right click on transform, then click on reset in order to move it to the center of the world. And what we can do is scale it up. Let's click on this button to constrain the scale on all the coordinates. Then I'm going to set one of the values on a coordinate to like 10. This is how it looks like. Let's set it perhaps to 20, something big. Okay, this is enough for our purposes. We can create a nice level here. Let's import more models into the scene. We have a tree, we have a statue, and we have a column here. What we're going to do is save these objects to our project. Indeed, we're going to create prefabs, but before we do this, we're going to set these objects up. Let's start with the column. We want these to be obstacles for the player, so the player cannot move through them. We need to add a collider to these objects. So let's go here, add components, and I'm going to type collider. And here we have the box collider. We also have a lot of other collider types, but we're going to focus on the box. Here, if I click on this button, this will toggle the gizmos. Right now, when I was working, the gizmos were disabled, and we can disable them again. Displaying the gizmos will allow us to see the boundary of the box collider. With this bright floor, it's not very visible, so I'm going to click on the floor, and we can deactivate an object by clicking here on this checkbox. There's also a nice shortcut. It's Alt-Shift-A. We can quickly enable or disable an object in the scene. Now let's click on this column and hit F. I can see that the box collider is nicely covering the shape. And if you're bothered by the sky in the scene view, we can go here and disable the skybox. This will allow us to design our scene in peace without being bothered by the sky. And here we have some objects, for example, the camera. I don't usually like to have these icons here, or at least not as big as this. This is our light and this is our camera. What I usually do is go here, let's click here, then I can reduce the size of the 3D icons, something like this. By the way, I'm using right click on the scene view, so if I use right click, I'm able to move the camera in an FPS fashion, like you're playing an FPS game, and with WASD I can move the camera around. This is another way to navigate your scene, and if I hit shift, I'm able to move faster. Here we have the parameters of the camera. So this is the scene camera. This is not our camera that's present here, our main camera. This is the scene camera specific to the scene view. We can modify its field of view, and we can also change the speed of the camera if we want it to move very fast by default, something like this. So when you're editing a big level, this can come in handy. But if you have a smaller level like we have here, perhaps it's a better idea to reduce the speed, something like 0.2. Yeah, this is great. And if you want to accelerate, just hit shift. Okay, so now we've set up this column. It has a nice collider. Now we can save it as a prefab. Let's go to our content folder and let's right click, create, then folder. Then let's create a prefab folder or prefabs and hit enter. Let's double click on it. Let's right click here, create folder. Let's call it something like environment. This will contain the prefabs of our environment. And what we're going to do is drag and drop our column here. Okay, so you'll notice that the icon has changed. In the hierarchy, you can see that our tree and statue have this icon. It's a box with a grayed face. This is what's called a model prefab. And when we drag a model prefab to the project window, it has created here a prefab variant because the icon is this blue box with one face that has diagonal lines. This is not a prefab, but rather this is a prefab variant. I will not dive into this, but a quick way to fix it is to go into the prefab. So let's double click on column here. And what we can do here is right click, then go to prefab, then unpack. That way we remove the link to the model. And when we save, the prefab will have a blue box icon. In prefab mode, I usually disable this autosave feature because I don't like that it saves and possibly slows down the editor every time I change a little property. So I disabled it, but if you have changes on your prefab, if you try to exit prefab mode by clicking on this arrow, it will notify you that you have unsaved changes anyway. So here you can see that we have a blue box. So this is a proper prefab. For the statue and the tree, let's click on both. And also for the character, I'm hitting Control, then clicking on the character. Then let's right click, let's go to prefab, then unpack. Now these are simple objects, not model prefabs. Let's do the same for the statue. Let's create a box collider. So we're going to add a new component, then choose box collider. And let's do the same for the tree. Let's add a component, then box collider. And I'm going to drag each of these elements here, the tree and the statue. Okay. Now these are prefabs. We can safely remove them from the scene. So let's select them all, then hit delete. For the floor, let's add a box collider. So let's click on add component, then type box and look for the box collider. Now, since the scale is set at 20, perhaps we will not see the box collider properly. So let's reset the scale to 1. And here let's edit the parameters of our box collider. So our box collider is at 0 and it has a size of 101, which is not good. We don't want the collider to have 0 in its size. So let's reset the size to 1. And instead we're going to move it down. So if we move the center down by half a meter, so let's set the value to minus 0.5, then we will have a collider that looks like this, which is perfect for a floor. So we have a thick floor here, and now let's reset the scale to 20. And you can see that everything has been scaled up by 20, even our box collider, but it's okay. We have a very thick floor. Let's also save the floor as a prefab. For the rest of the models, I'm going to do the same thing. So I'm going to lay them out in the scene here. Okay, we have walls, we have a destroyed column, and we have a block here. We will use all of these assets as obstacles in our level. So what I'm going to do is I'm going to select them all, then right-click, prefab, unpack completely. What we did here is we severed the link between these objects and the model files here, the FBX files, with all of the models selected. Let's add a component box collider. We have a box collider on each of these items. For the destroyed column, this is fine. For the walls, it's also fine. Perhaps for this banner, let's make the collider a little bit smaller. We don't need it to be as big. Let's go to the box collider component and let's change the size, perhaps along the x-axis. Let's change it to make it more narrow like this. And perhaps let's also change the size along the z-axis. Something like this will do. As for the rest, let's keep it like that. It's fine. Let's select all of these objects. So I'm going to click on this one, then shift and click on the last one. Then I'm going to move them all to the environment folder. And this has created all of these prefabs. One last thing we can do is select all the prefabs. Then we can go to transform, right click, then reset. It's always a good idea to reset the transforms on your prefabs. It seems to have also reset the scale on the floor. So let's restore it to 20 and we can delete these prefabs since they are saved in this folder. Okay, now we have this folder with these prefabs. These prefabs are basically game objects that live at the project level. They don't live in the scene. At any time, we can take a prefab here. And by the way, you can choose whether you want to display these as thumbnails by using this slider here. You can choose the size of this thumbnail, or you can drag it all the way to the left to get a list view like this. We can drag and drop any prefab to the scene. If we drag and drop our tree, here you can see that it has the components that we configured earlier. It has our box collider and any other components that we may add here, which is very nice. Now to create a level, it's a good idea to enable grid snapping. You can enable grid snapping by clicking on this icon, and here you can choose the size of the grid. Let's set it to 1. Now if I move this tree around, I'm going to use this square between the X and Z axis. If I drag this tree around, you can see that it moves by an increment of 1. But here in the position, you will see that the position is a little bit awkward. It's not exactly a whole number. What we can do is click on this drop down list here, then click on align selected all axes, and this will align our object back to the grid. So now it's at 3, 0, minus 6, which is a whole number. Okay, we can move it around like this. Okay, let's design a level. Let's put some obstacles in the boundaries of the level, for example here, and let's choose a snap-in value of 0.25. And I'm going to duplicate my tree a bunch of times with Control D. Okay, these are enough trees, I believe. Since these have colliders, our character will not be able to go through here. This is not exactly level design. Since we have 3D models ready to use, we are doing a mix between environment and level design, because level design is all about creating the space where your player will navigate. It's not about deciding what an obstacle is. We are doing both at the same time. We're thinking about where the player will go, and at the same time we're deciding, oh, is this a column or is this a tree? But it's okay, since this is a small project, we can get away with it. But in your games, it's better to separate between the two disciplines of level design and environment design. Let's add a few columns. Let's add a few to the center of the scene, for example here, and let's duplicate it and add it here and here. Let's add a destroyed column, something like this. Now let's add a few blocks. I'm going to add one block. I'm going to click here, then align to all axes. And I'm going to place these blocks at the edge of our level, something like this. You can make it look nice, but by not completely aligning them together, something like this would look more organic, perhaps. Okay, then let's add perhaps some walls here. Here we have a wall. Let's rotate it. So I'm going to quickly switch between the move tool that we've been using so far and the rotate tool. I'm using E. You can find the default keyboard shortcuts here, edit shortcuts, and here you will find all the shortcuts that you can use, and you can see the binding conflicts, and you can export this preset and also import it. The Unity editor is very customizable. Let's create a wall here by pressing E. I've switched to the rotate tool. You can also click here on this little toolbar, and with grid snapping enabled, if we go here, you will notice that the rotation is snapping to 15-degree angles. If you rotate around the y-axis, which is represented by this green semicircle, the rotation will snap to 15 angle degrees, which is nice. I like it. Okay, let's have a wall here, and let's Control D and have a wall like this. Control D. Another wall. Let's have it a little bit at an angle. Then let's add a wall corner perhaps, and let's have it somewhere here, and add another wall here. Let's click here, align all axes, and here as well align all axes so they align more or less. Perhaps this one, there's no need to rotate it like that. Okay, we need to select all of these walls, then go here and align with all axes so they can snap together. Okay, so they're snapping perfectly, but we don't have to have such a perfect alignment. It's not always preferable. Let's have some trees here perhaps to fill this gap. Control D, and I'm going to create a bunch of trees here. Okay, then let's have the rest of the wall here. Let's just click on this, shift click, and perhaps we can duplicate this, Control D, and move this over here. What I'm thinking to do is perhaps Control D and have another wall section here and move this corner over here like this. Perhaps we can rotate it. Yeah, we want it on the other side, and then we can move it like so and have the other side of the wall here. Then perhaps we can add the gate here in between. Let's click here, align all axes, and we can rotate it, then move it to snap with the other walls. Then perhaps we can duplicate this wall. Let's move all of these out of the way. Okay, something like this. This looks fine, and yeah, we can save some time. Let's just copy these blocks. Let's shift click on all of them and So here, if I want to rotate them, you can see that we are rotating each individual block around its origin point. But if we go here and choose center, now we can rotate all the objects around the common center. So let's duplicate these objects, Control D, and let's hit W and move them down here. Let's create something like this here. I want to rotate them like so, or perhaps let's put them on the other side here. Okay, and perhaps let's have a statue. Let's also add a few bricks here and there. Let's add some bricks here and here and here. Now let's just add a bunch of trees at the edge of the levels. So I'm going to select all of these trees, then I'm going to Control D to duplicate them and move them over here, then over here as well. If you want to ignore grid snapping, you can hit Control while rotating or moving objects. So here, if I want to move them with more precision, I can hit Control. And perhaps here we can add some columns to close this gap. Let's close the rest of the gaps using some blocks. We can also use the Rect tool. If I click on Rect tool, we can scale objects with more ease. For example, here I can scale from this side or scale from this side. And let's do the same thing over here. Let's click on this block and scale on this side. Okay. So now we have an enclosed level, which will help our character stay inside of the level. Our hierarchy now is a bit of a mess. Let's click on the first tree and let's select the last one. We can group all of these objects into one parent object. Let's right click, then create empty parent. It's called game object. Let's right click on it, then rename, or we can also use F2. If we hit F2 on the keyboard, we can rename it. Let's call it environment or level geometry. Now you'll notice on our game view, our camera is somewhere around here. This is our camera. It's looking at the trees. It's not supposed to be here. We're supposed to have a top-down camera. What we can do is move our camera over here. I'm going to move the scene view camera like this. Then I'm going to select the camera and we can go to game object, then align with view. And this will align the camera with the viewport camera or the scene view camera. This is our camera here. Let's edit the rotation. Let's have the rotation on the x-axis set to 45 degrees. And let's have the rotation on y set to 0 and z set to 0. The z rotation is the roll. It's a little bit unsettling when you change it. So let's keep it at 0. But the FOV of the camera could be better. An FOV of 60 is perhaps too much. Let's reduce it to something like 30. Yeah, this looks good enough. And here we are seeing these gizmos in local mode. These are the gizmos of the camera pointing at the rotation of the camera. But if you want the gizmos to be relative to the world coordinates, we can go here and choose global. That way we have gizmos to move the object around the world regardless of its rotation. Perhaps to view the character better, we can move the camera back a little bit and we can move it down a little bit. And the reason why I wanted to point in this direction is because the Z axis of the camera, also called the forward axis, is aligned with the forward axis of the world. You can see it in this little gizmo here. We can also switch from global to local. You can see that pretty much the forward axis is aligned with the world. Later on, when we create a camera controller, it will be easier to control the camera if it's aligned with the world. Here, perhaps we can edit the directional light. Let's click on it and perhaps let's change the rotation of the light. This is our light here. Let's look at the game view and change the Y rotation. Let's choose a value around 60 so that the shadows are pointing in that direction. You can also change the pitch. Here it looks like a scene in the afternoon or close to sunset, and this is closer to midday. So let's keep it at 30. We can increase or decrease the intensity of the light. Let's keep it at 3. Let's look in the scene view. An intensity of 3 looks good enough. Now let's add more prefabs. We have more models here. In my extra objects folder, I have a floor details object. Let's drag and drop it in the scene. Right click, prefab, then unpack, and I'm going to save it as a prefab. Let's go to environment and save floor details, no floor. And now let's move it around. Let's add some details just so the level looks a bit nicer. I'm using Control D and moving using the move tool. It's all a matter of taste. Adding too many details all over the level does not usually look good. You want to leave areas empty for the eyes of the player to rest, and you want to add detail in more or less a logical sense. But here we're not really focused on the aesthetics of the level right now. We just want something playable. Okay, let's go back to the top of the hierarchy. Let's collapse this level geometry object. Now we've added these details. Let's select them all and drag and drop them to the level geometry object. So they are parented to it. Now the level geometry object has all our geometry. We can Alt-Shift-A to hide it. But I see that we still have a floor. Yeah, the floor is not part of the level geometry. So let's add it here. Okay. Okay, now we have the level geometry. Then we have our character. This is our player character. What I'm going to do is click on the root object. Then I'm going to rename it with F2. Let's rename it to player. Then I'm going to drag and drop it on the prefabs folder. This way we have a player prefab ready to edit. All right, we have created a nice level for some gameplay to take place in. We've seen how to import models from the internet, how to unpack them, and how to convert them to prefabs. We've added box colliders, and we've created a nice level for us to play in. In this lecture, we're going to introduce C# programming in Unity. We are not going to take an academic approach. What we're going to do instead is discover these concepts all throughout the course. However, I still wanted to give you the most important concepts that you need to be aware of in order to get started with C# with ease. The C# language is huge. There are a ton of concepts that you need to wrap your head around, and even more so with Unity, a lot of code is added by Unity in C# that allows us to control a lot of things around the engine. This adds a lot more complexity to the whole thing, and this could get overwhelming very fast. So the right path to learn is not to try to understand everything at once, but trying to take these concepts one after the other and understand how each concept operates. But ultimately, I can say that programming is fun. It's like having an infinite number of Lego blocks at your disposal, and you can use them to create anything you want. So it's really a skill that I encourage you to learn even beyond this course. But after years of programming and using Unity, I'm going to give you what in my mind is or are the most important concepts. And for this, we'll see an example. Let's open Clip Paint Studio. I'm going to use this all throughout the course, and I'm using it in all of my tutorials as a blackboard. Let's say we are playing a game of tennis and we're having fun. So you're on your side of the court and I'm on this side. And let's say we want to keep track of the score. What we do is we bring a chalkboard by the side of the court. We draw a line in the middle of the board, and on this side I write my score, and on this side you write your score. This chalkboard is a nice way to keep track of the score without having to memorize it. Let's say we are having so much fun that we forget the score. In this case, this is a nice way to keep track of the score. Now let's get into some terminology. Now the value of the score, let's call it the value, and the chalkboard itself is like a container that contains that value. And this is an important distinction. Let's say we didn't have this chalkboard and we just kept track of the score in our minds. Let's say we have spectators that come in the middle of the match. If they don't have a chalkboard of some display of some kind, they will not know who has scored what, or in this case we'll have to tell them the score. So the value itself is like an abstract notion that doesn't exist in the world unless it is written somewhere, unless it is stored somewhere in a container, or in this case a display. We could have a digital display, a chalkboard, or a piece of paper even. And this is an important concept that you're going to use all throughout your game dev career. This is the concept of a variable. Instead of using the term container here, we can say that this is a variable, and this example illustrates the use of variables really well. You can think of a variable as a container of a value. You can think of it as a chalkboard or as a box. This box has a name. For example, we can call it age, or in this case, let's call it player 1 score. And we can call the variable on the other side of the chalkboard player 2 score. This container not only has a name, but it also has a type. Here we are using numbers, and we can distinguish between whole numbers. We call them integers or int in C#. We can have floats, and floats are numbers with a decimal point. Examples of ints, we have 1, 3, 55, 101. So whole numbers. And examples of floats are 4.5, 2.25, 100.56. And in C# we also have doubles. A double is like a float, but it's much bigger. If a float was a container of this size, a double is a much bigger box. A double number can reach much bigger values than a float. In C#, to distinguish between floats and doubles, especially when we have these simple values here, we add an F at the end. So we can say 4.1F, 2.25F, and 100.56F. We can also have text. In C# we call it string because it's a string of characters. To write a string value, we have to enclose it between double quotes. We can have values like double quotes, Unity, and end with double quotes, Zeus, YouTube, and any string of characters you can think of. We also have another type of variables called a boolean. A boolean, you can think of it as a flag. For example, in our tennis match here, let's say we have a blue flag over here. When this blue flag is raised, it means that it's my turn to serve. And when the blue flag is not raised, it means that it's your turn to serve. A Boolean value can exist in two states. We have the true state and we have the false state. If we go back here, let's also illustrate our Boolean values here. They can be either true or false. All right. What I explained just now is the concept of a variable in programming, and especially in C#. Now, these types of variables are what's called primitive types because they are simple values. We have numbers, we have strings, we have true or false, but we can have more complex variables. For example, let's say this is your bank and the bank stores records of its clients, and your record may look like this. We have an account ID, a name, and a date, and the bank has to store these informations for each client. If we go back to our first example here, this box will no longer be sufficient. We cannot store the name and for example, the date that the account was created on and the account ID. We cannot store these in separate boxes. We need a big box to store all the information for one client in one place. So this is still a variable, but it's no longer just a primitive variable like we saw here. This is in fact an object, and more accurately, it's a class. A class is like a description of what an object is. So in the class, we will say that we have an account ID of type int, we have a name of type string, and we have a date of a given type. Let's say it's also an int or a float, although we have a type in C# called date or date time. Just for illustration purposes, let's pretend that this is a float. So this is in fact the class, and an object is the instance of that class. It's the actual object in the system. Let's remove this line here and let's use this record here. Now the object is the actual record that's stored in the bank. Let's say we have a record where the account ID is this number, and we have here a name and we have a date in which it was created. So let's recap. A class is a description of what an object is, and the object is the actual instance of that class in the system or in your game. And you can think of an object as a variable. It's a much bigger box, but instead of containing one value as we have here with primitive variables, it can contain many variables. And the great thing about objects is they can contain other objects as well. For example, here we can have a lot of fields. We're not limited by the number of variables that we can have within an object. We can have a lot of variables, and each variable can be an object in itself. Okay, now let's get some terminology right, because knowing the exact name of something will give you a chance to look for it online. If you go online or on a forum and say class variables, people and search engines may not understand what you're talking about. When a variable is inside a class, we call that either a field or a property. We can also call it an attribute of the class. There are some slight differences between all of these terms, but this is what we use. Now, what's great about a class, and by extension its instances, is that it not only contains data, but it can also contain some functionality. We can have actions stored within the class. For example, let's take this account class here. Let's say our account has an ID, a name, a date, and a balance. Now we can add some functions to do things in the account. We can have a function to increase the balance of the account, a function to delete the account, or a function to print the account, for example, on a piece of paper. In other programming languages, these are called functions. But again, if you want to have the right terminology, a function that's within a class is called a method. These methods will perform actions inside of the account, and by these actions we usually mean that they will change the information or the variables inside of the account. Let's say this increase balance method will not only increase this balance by a certain amount, but it will also send an email to the owner of the account, notifying them that you have some money in your account. Sometimes people refer to class attributes, and by this I mean these variables, as the state of the class or of the object, and these methods will change the state of the object. This is also a valid term to use. And now perhaps let's talk about another concept. If this is new to you, don't hesitate to take a break to watch the video again. But let me introduce you another concept. Now let's say I work for the bank and I have free access to every account in the bank. Let's say I open this account, so I have free access to the balance on that account. Let's say here this is the balance. Let's say this person has $120 on their account. If I have free access to this field, then I can change it as well. So for example, let's say I want to add $5 here, so I change the value from 120 to 125. Because again, I have free access to this field. But what will happen? As I said here, this increase balance method will not only increase the balance float, but it will also send an email to the owner of the account and perhaps also do more things here. Perhaps it will contact the other bank and subtract the money from the account of the sender. So we can have all sorts of things here, of actions that we can execute. But what will happen if I just change the value to 125. By doing that, I'm only changing the balance and not doing any of this. And this is a problem. This is why we have something called access modifiers on the attributes of our class. An access modifier can be either, let's take the balance for example. So the balance can be either public or private. Now with the public field or attribute, I am allowed to do this. Other scripts in my program can access this value and change it. So here, as I said in my example, if I have a computer and I access this account, I can change this value as well. However, if it was private, we can represent a private variable by the minus sign. If I have minus in front of balance, it means that this is a private variable. And for private variables, The only entity that's allowed to change them is the object itself. In other words, the only way we can change the balance is within one of these methods inside of the account, which is great because we don't want other scripts to accidentally change this value and not execute the actions that we want to execute after the balance has been changed. And this could be a problem even when working alone. Even when you work alone on games or programs, you may accidentally set the value of an object attribute without being aware that it's not enough just to change that value. You have to do other things. And especially when you work in a team, other team members may not be aware that some values cannot be just changed like that. So instead of giving free access to these values, we can provide methods that will change the values of these variables in a somewhat controlled way. Now, the last concept that I want to talk about is inheritance. And this is an important concept to get started. And to illustrate this, let's say we have different classes. We have a car, a truck, and a boat. Now, each of these entities in our game will have a color. So let's define a variable here, color. We're going to need to define a new attribute on each class, color, color, color. But this is redundant, and especially when you have a lot more attributes, it's much better to use a concept called inheritance. So we're going to remove this member here, and instead we'll create a base class, or you can also call it a parent class, and all the other classes will inherit from this class. Let's call it vehicle. We can say that a car is indeed a vehicle, a truck is a vehicle, and a boat is also a vehicle. This relationship can be represented by inheritance in programming. Here we can define the color attribute on our vehicle, and it can be inherited by all the classes below. Now let's say we have some functionality here. So we have the color attribute. We also have the change color method. By doing this, we are changing the color and perhaps also doing other actions in our game. And these classes down here will also inherit the methods defined in the parent class. Now let's talk about the access modifiers. Here I said that a variable or an attribute can be either public or private, but in fact we have a third option. We have the protected attribute. Now for the color, if I set it to private, then in the child classes I cannot access the color. But if I set it to public, and public properties or attributes are represented by a plus symbol. If I set it to public, now other scripts or other classes can access that color and change it at will. And this is not what we want. We want to keep this color private, but also give access to the child classes that inherit from vehicle, so they can also access it. In this case, we declare this color as a protected variable. I don't remember how we represent protected variables. So this is the UML representation. It's a way to represent your classes and the relationships between them. But let's say this is a protected variable. Now, if we have a protected variable, this can be accessed by the child classes and changed, but other scripts outside of the vehicle and its children cannot access this variable. This is a way to kind of protect us from ourselves and protect the code from changes that will go against the functionality of the classes. All right, let's recap. In programming, we have this important concept, which is called a variable. A variable, you can think of it as a box that contains a value. These are simple values like numbers, true or false, and strings of characters. But we can also have more complex values. These are called objects. An object is an instance of a class. You can think of a class as the description of that object. The object itself is the actual values that we have. You can think of this as like reading the description of an object online. For example, if you have an iPhone, you read the description of that iPhone, how many megapixels it has in its camera and all of that stuff. This is the class that you're reading, but the actual iPhone that you have or that your friend has, that's the actual object, which is an instance of that class. So for example, the object may be broken. You could have an iPhone with a broken screen, but that doesn't change the concept or the class of the iPhone. The iPhone is still the iPhone. It doesn't matter if yours is broken. So it's important to distinguish between the notion of a class and the notion of the instance of that class, which is an object. And we talked about the fact that objects are not just containers of data. They can have actions as well, and we call these methods. These methods are usually used to change the state of the object, and by state we mean the fields of the object and perhaps also the fields of other objects. We talked about the concept of access modifiers and how each variable here can be either public, private, or protected. And finally, we talked about the concept of inheritance, in which we have child classes that can inherit from one class. And especially in C#, we're not allowed to have classes inherit from multiple classes. Each class can have a maximum of one parent, but a class can have virtually an infinite number of child classes. That's not an issue. We said that child classes will inherit all the attributes, properties, and methods that are defined in the base class, and we can have multiple levels of inheritance. We can have class C inherit from class B and class B inherit from class A itself. In this case, class C will inherit all the methods and attribute defined both in B and A. If you're new to programming, this is a lot to take in, so don't hesitate to watch the video again, perhaps at a slower pace, but this is pretty much what programming is all about. These are the most important concepts in programming, and especially programming in C# inside of Unity. And throughout this course, we will discover more concepts little by little and discover how we can use them in practice. In the previous lecture, we got to understand how code works in general. These are the concepts that we saw. You will find these concepts in pretty much any programming language. You only have to learn them once for one programming language, let's say C# in Unity, and then you can apply the same principles and just change the syntax for C++, for example, on Unreal Engine, or even on its own. If you want to make your own game engine at some point, you can apply the same principles in Python, for example, for developing applications, websites, and all sorts of things. A lot of things run on Python, and a lot of software can be extended using Python. These concepts are important, and while the last lecture was more of a theory, let's say, and I hope you guys were able to follow along, this time we're going to apply what we've learned here. Let's talk about C# in Unity. So now that you know what the concept of a class is, C# in Unity is still C#, except Unity has given us a whole bunch of classes that we can work with. We have the game object class. Like I said previously, every object in your scene and even in your project, if you have prefabs, every object is a game object. So we do have the game object class provided to us by Unity, but we have more classes. Each component of your game objects is a mono behavior. It's simply a class called mono behavior. Let's start slowly and learn how to write code in Unity. Let's create a new folder. I'm going to right click, create, then folder, and let's call this folder scripts. This is where we'll write all of our C# code. Let's right click here, create, then create a mono behavior script. Let's call it hello script. I'm going to double click on it to open it in Visual Studio. And by the way, you can use Visual Studio and you can use pretty much any text editor that you prefer. In Unity, if we go to Edit, Preferences, External Tools, here you can choose what external script editor your code will open in when you double click on a script. We have the choice to set Visual Studio by default, and we also have the option to choose another, so you can browse and find your application. Okay, let's go back to Visual Studio. So the interface here is pretty straightforward. It looks like a project view here where we have our script files. With the script open, I can click on this button to sync with the active document. This will actually unfold the whole hierarchy of the script and will show us the hierarchy of folders of the script. So this script is in assets scripts. And here we can see that it has a default code already written in it. We can go ahead and delete most of this. Let's delete using Unity Engine, and let's simply have a simple class. This is how we declare a class in C#, public class hello script, and we open and close these curly braces here. The body of the class will be contained within these curly braces. Now let's create a variable, or as we said in the previous video, an attribute of this class. Let's call it age. It will be of type integer. Then let's have a string name. After each declaration, we end the line with a semicolon. Now let's define a method. Let's call it increase age. Here we say void because this method doesn't return anything. You can imagine methods like black boxes. We give them some input and they give us some output. The output is defined here before the name of the method. And then for the input, we can specify it here, for example, int number. This is called the signature of the method or the function. Here it says that it takes a number and doesn't return anything. To increase age or to set any variable to any value, say age equals a number, for example 10, then we write a semicolon. Now in order to increase age by this number, we can write age equals age plus that number. Now what this will do is we will use the value already stored in age and we will add the number to that value. Then we'll store the results of this addition into the age variable. Okay, let's save our script. I'm going to hit Ctrl S or click on this button. So this button saves all files and this one saves only the opened file or the active file. Let's go back to Unity. Unity will recompile the scripts as soon as it detects a change. Okay, let's add this component to our player. Here we have our player object. Now I'm going to drag this component and drop it on the player, but I have a problem. It says can add script behavior hello script. The script needs to derive from mono behavior. We've already seen the concept of inheritance. When we say that a class derives from another class, it means that that class inherits from something. And here basically this dialog says that hello script needs to be a child class of mono behavior. So let's change that. Let's go back to Visual Studio, and to make a class inherit from another class, in front of the name of the class we type a colon, then we type the name of the parent class, in this case mono behavior. But here we have a problem. In programming, your IDE, for example here Visual Studio, or even the Unity editor. Let's go back to the editor. So here we have a console. Any error that you have on your code will be shown either here or displayed inside of your IDE. And all you have to do is hover the mouse cursor over the problem, which is underlined by red. And it's important to understand these error messages. They will help you to fix problems in your code and guide you along the way. So it says the type or namespace mono behavior could not be found. So basically our script doesn't understand what mono behavior is, although it exists. It is inside of the Unity engine, but in order to use the classes that are provided by Unity, we need to use the Unity namespace. Let's go up here and type using Unity engine, and then a semicolon at the end. It still doesn't recognize it, but perhaps the B needs to be uppercase. Okay, now it recognizes it. A namespace, or in Java they're called packages, is simply a package like the name in Java suggests, a package where you have a whole bunch of classes. And here Unity is providing us with a big package called Unity Engine. If you want to use it, you say using Unity Engine. We can also group our classes in our own packages or our own namespaces. Let's say here, let's define a namespace. Let's call it Zeus Unity Crash Course. And we need to enclose our class within curly braces inside of that namespace. So I'm going to hit Ctrl X, then Ctrl V. And now my class is within the block defined by these curly braces inside of my namespace. And now in other scripts, whenever I want to use my hello script class, I'll have to do using Zeus Unity Crash Course. That way, classes within that namespace will be available to me. And the term namespace is also important because if you have classes with the same names in different namespaces, your compiler will not have a problem with it. However, if you have two classes in the same namespace, let's say class A and also class A. Now the compiler will have a problem with it, and here we have an error. The namespace Zeus Unity Crash Course already contains a definition for A, so this is not possible. Let's go back and remove this namespace and also remove the curly brace at the end. And I'm going to select all of this and hit Shift Tab to remove the tabs on the left. Now for classes that don't exist within a namespace, C# has a sort of empty namespace. So even if you don't declare your classes inside of a namespace, if you want the accurate term, it's called the global namespace. It's okay for small projects, but as your project gets bigger and as you use more third-party assets, maybe the names of your classes, if you create a class called weapon or vehicle, maybe it will clash with another class in another package. In this case, it's better to write all your classes within a namespace. And by the way, you are free to choose the name of your class. You just have to be careful that the file and your main class have the same name. And also for the namespaces, you can choose any name you want. Okay, now that our hello script is a monobehavior, let's add it to, first let's save. I'm going to hit save. Then go back to Unity. Unity is importing the assets and compiling the code. And now, if I do this, so I'm going to drag my hello script here and drop it on my player. Now it's a component. So all we needed to do is inherit from monobehavior. Now Unity recognizes this script as a proper component that we can add to game objects. But here we don't have anything on the inspector. We would like to display the values of age and also the name. Let's go back to Visual Studio. In order to display these values, we can either set them to public. If an attribute is not declared with anything, we have mainly 3 access modifiers that you're going to use most of the time. We have others, but I'm not going to go into that right now. We can have a member or an attribute be either public, like this, or private, or protected, or we can simply not write anything and it will be private by default. Now, in order to display age and name on the inspector, we have to either set them to public like this. And if we go back to Unity, we will see the values here, age and name. By default, all numbers are initialized to 0 and all strings are initialized to an empty string. We can set a default value here. Let's add another method here, void print values. It's not going to take anything. It will just print the value of age and name. To print a value on the Unity console, we can use debug.log. Here, debug is a class provided by Unity. If you hover over it, you can see that it's declared as unityengine.debug. And in order to call a method on a class, we can use .log and write something. Hello world, for example. Now, normally you can only call methods on objects, not classes, but this is a special method. This is a static method. This is yet another concept that I'm not going to explain right now. Let's use debug log and let's type my age is, and here we need to add the value of age. We can do it this way by using plus and type in age, then plus, then another string, and my name is, and here we need the value of name, so we type plus name. Okay, we don't write the name inside of the string. This is called a string literal or a string value. It's simply a value that doesn't exist inside of a variable. If we type my name is name, all we're going to get on the console is this, and my name is name, but we actually need the value inside of this variable, not just the name of the variable. Now let's define some methods that Unity provides us by default. We have the start method. Let's declare it here, void start, and void update. These are some special methods also called Unity callbacks or Unity messages. When you click on this play button and when the scene starts, what Unity will do is it will go through each game object and each component on each game object, then call the start method on each one. All we have to do on our script is declare a start method. It doesn't matter if it's private, public, or protected. We just need to type start, and this will be called at the start of the scene. Let's call our method here print values, and let's add the parentheses and then the semicolon. Now if you save this and go back to Unity and run the game, now if you go to the console, it will say my age is 0 and my name is blank, because in fact we don't have any value here. Let's go back to our player and let's set the age to, for example, 21, and set the name to Victoria, for example, and let's run. Now it will say my age is 21 and my name is Victoria. Now let's explore another method or Unity callback that Unity calls on every game object. It's the update method. Here our game is running right now. If we go to stats, we can see that the game is running at approximately 60 frames per second. In every frame, Unity will call update on all the components, on all the game objects in our scene. So let's go back to our script and let's define the update method. I already defined it here. Let's call print values here. So I'm going to cut here and paste it here. Then let's go back to Unity. I'm going to hit play. And here you can see that we have a ton of messages. Every frame it's printing my age is 21 and my name is Victoria over and over again. Okay. Now let's do something a little more interesting. Let's call our other method here. Before we print the values, let's call increase age by 1. Every frame will increase the age by 1. And you can imagine that with 60 frames per second, the age will increase by 60 every second. Let's run the game. So here nothing happens because, I didn't save my script. I need to save it before going back to Unity. And now Unity is compiling the scripts again. You can see a little progress bar here. Not a progress bar, but like a radial bar. And when you have a check mark, it means that it has finished. Now let's run again. Okay, so the age is increasing. We are already at 200, 300. Okay, now using our methods is great, but we want to access the objects in the scene, starting with the components on our objects. We can already access the game object itself. Let's minimize this like this and perhaps auto hide this. Okay, we can already access the transform. All we need to do is use transform dot position. So we have access to this position. We have access to a lot of things. So here, using IntelliSense in Visual Studio, I'm able to see all the fields and methods at my disposal. There is a slight difference between fields and properties, but it doesn't matter. We will discover the difference in time. You can modify the position, the rotation. So let's modify the rotation. Rotation equals. For rotations, in Unity, we use quaternions. Quaternions are containers for the rotation of an object on all the different coordinates, x, y, and z, but with a little bit more stuff in it. And in order to use quaternion, we can say equals quaternion dot Euler. And here we can type the Euler angles on each coordinate. For example, let's say 90 degrees on the x-axis, 0, then minus 90 degrees on the z-axis. And here you notice that I'm typing 0f, 90f. Like I said in the previous video, since these are floats, we need to type f at the end. If we don't, the compiler will consider that these are double numbers. That's not exactly what we want. Most of the time you'll use floats. The Unity engine uses floats everywhere. So for numbers with decimal points, that's pretty much what you're going to use. Okay, at the start of the level, we're doing this. Now let's disable these lines. We can disable them by typing a double slash at the beginning of the method or the instruction like this. In Visual Studio, we can do this automatically by selecting all of these lines, then go in here, comment, and we can also uncomment. This is called a comment, and we can type whatever we want here. This is just to document your code. Here, let's type rotating the object at the start of the scene. Okay, this is just to remind ourselves what the code is doing. We can also have a multi-line comment. For this, let's type a slash and a star, and then we can type whatever we want here over multiple lines. And then to end it, we type star then slash. This is a multi-line comment. Okay, now let's execute our code. Let's start the game, and just as we said in the code, the rotation of our player is now set at 90, 0, minus 90. Now, when we go out of play mode, all the values of our parameters are restored and our character is upright again. Now, let's rotate our character over time. Let's go back to our code, and instead of doing this, let's comment this line, and in the update method, let's say transform.rotation equals transform dot rotation. Since these are quaternions, our rotation is a quaternion. The way to add two quaternions together is to use a multiplication. So if we multiply a quaternion by another, we are indeed adding the two rotations. What we are going to do is add the value of our current rotation, which is transform dot rotation, to another value, quaternion dot Euler. And for this value, we're going to say 0, 5, 0, and if we run the game right now, this is what we're going to get. Here our character is turning, but the problem here is that this is pretty much dependent on the frame rate. If we click here on this drop down box, by the way, here you can set the resolution of the game window or the game view. If we disable VSync, our character will turn much faster, and in the stats we can see that now the game is running at like between 120 and 150 frames per second. In your games, it's usually a bad idea to tie your code with the frame rate. If some people have a crappy computer and the game runs slower, maybe the game for them will be easier, and for people who have a faster computer, they will be punished because the game will be incredibly hard. Imagine that the speed of enemies or bullets is dependent on frame rate, then it will be very frustrating if the game moves very fast. In order to mitigate this problem, what we're going to do, and Unity provides us with another class called time. In the update method, we can actually get the number of seconds that have been elapsed this frame, and we can get this number using time dot delta time. Now the formula for speed is equal to distance divided by time, and it's also the same for a rotation. So we need a speed, or more specifically an angular speed. Let's declare a variable here, float speed. Let's set it to 10 degrees per second. And here, in order to get the distance or the angle that we need to rotate this frame, we can multiply the delta time by the speed. Let's bring up the calculator. If we have 60 frames per second, let's divide 1 by 60. This delta time value will pretty much be equal to 0.016, or in other words, this is how much time the game spends on every single frame. Of course, provided the game runs at 60 frames per second. If it's more than that or a little bit less than that, then the delta time will change. But this formula will guarantee that no matter how delta time changes, our gameplay will be consistent. Okay, now let's go back and let Unity compile the scripts, and we're going to run the game again. Now our character turns at 10 degrees per second. It's actually very slow. Why don't we expose the speed variable to the inspector? So we're going to stop the game and go back to the code. Now let's cut this. Of course, the editor will bark at us. Hey, speed does not exist in the current context. Okay, we know. So it's very useful in showing you exactly the problems in your code. So the editor is really helping you along the way. Anytime you forget about something, it will tell you about it. Let's define it up here. It's just a convention that we need to define the members on the top of the class declaration. There's nothing preventing us from doing this. For example, if I want to have my variable on top of the method, the only thing that the compiler cares about is that this declaration is outside of any method. So this is the body of the method defined between these curly braces. The compiler will only recognize this as an attribute of the class if it's declared outside of all the methods. And of course, within the body of the class. But if we do it like this, then this is not a class attribute. In this case, speed is what's called a local variable to this method. Okay, let's go back, Control Z. Let's put it at the top. It's usually a good idea to put your variable declarations at the top. It's just for more clarity because all your variables are here. If you had variables here outside of methods, you'll have a hard time, especially when your script gets bigger. You'll have a hard time reading your script, basically. Now we need to expose this variable to the inspector. In the beginning, I said that we can set variables to public and that would expose them in the inspector. But here we have a problem. As the project will get bigger and we add more scripts. Now in our case, if we have a hello script object, any other script can access age and name and change them as they will. As I said in the previous video, this can cause a lot of problems, especially, for example, if we want this class to control the age, if we don't want the age to be, for example, lower than 0 or greater than a certain number, we shouldn't allow other scripts to access this field freely and change the values as those scripts wish. We need to protect the variable by setting it to private, but we also want to show it on the inspector. And a solution for that is to write what's called an attribute. To add an attribute to a class field, we need to use square brackets like this. And then we need to type serialize field. This is an attribute provided to us by the Unity engine. If we hover over it, you can see that it's Unity engine.serialize field. And if we save, now we have access to speed in the inspector. It's set to 10 because that's the value that we assign it. And by the way, you can also assign default values to the other members. For example, here, let's say age equals 18 by default and name equals John by default, and let's run the game. Exposing values in the inspector allows us to change their value as we playtest our game. So now let's say this is too slow. I can change the value of the speed by clicking on the speed label and dragging the mouse cursor. This will increase the value. Let's set it to 300, for example, or minus 300. In this case, the character will rotate counterclockwise. And for the game window, now that something is happening, finally, something is happening on the game screen, we can right click here and maximize the game view. This gives you an opportunity to see your game in a bigger window. And of course, if you have multiple displays, for example, if you have a second screen, you can even undock this game window and have it as a standalone window on your second screen like this. And I believe this isn't by default docked here, so it's probably here by default, and what you can do is just dock it over here like this. I prefer to have this layout where the scene and the game window are open at the same time, and you can go here and save your layout. You have also default layouts. If you screw up something in the editor, you can go back to the default layout. This is nice, but since our character is not a shawarma machine, we will delete this script. So let's go to our character and let's click on these three dots here and remove component. Then we can go to project, scripts, and we can simply right click on our script, then delete. And this will delete the script, but this rotation script is still a good idea, but maybe will not apply to our character, perhaps to a coin. Let's go to content, models, mini arena, extra objects. And here I have a coin. If we place it on the scene, perhaps we want our coin to be a little bit above the surface. Let's disable grid snapping. We want it to be above the surface a little bit, for example, at 0.7 meters. And what I want to do, my idea is we want this to rotate exactly like we did for the character. We want this to be constantly rotating. And we also want it to move up and down a little bit like this. So let's create a prefab first. Let's Control Z. And we're going to create a new empty, create empty. This will create a game object with no component at all. But of course, as we said previously, Unity will still need to add the transform since it's not optional, it's mandatory. Okay, now we're going to call this game object coin. And for our coin mesh here, let's rename it to coin mesh, and here you'll notice that when I created my coin empty, it has been created at the origin point of the world. So all the values in transform, the position is 0, 0, 0, rotation 0, 0, 0. Perhaps for you it will be different. You can go to edit preferences, and here if we go to scene view, you can choose the 3D placement mode. I have mine set to world origin, but I guess this is not the default one. I've used this for so long that I forgot. You can choose scene intersection or scene pivot point. But for my purposes, I find that world origin works fine because anytime you create a new object, it will place it at the origin point. Now we need to click on our coin mesh and let's reset the transform. So our coin mesh is here and also our coin object. Now let's have our coin mesh be a child of our coin object, and let's move the mesh a little bit upward. Even 0.6 is good, or 0.7 like we said. And here on our coin object, we're going to save this object. Let's go to prefabs. Here we have environment. Let's create a new folder. Let's call it gameplay, and let's save our coin object here, and let's drag and drop our coin object here, and now we have a prefab for our coin. You can access a prefab in two ways, not only through the project window. We can also access a prefab on the scene. If we have a prefab instance, we can click on this little arrow here on the right, and this will make the editor switch to prefab mode. Here we can edit our prefab and we can choose the context. This is very important if you want to, for example, here we have the normal context. It will show all the other objects in the scene properly. We can choose to gray them out. All the other objects in the scene will be displayed with this gray material, which is very useful if you want to isolate your object. And if you want to isolate it even more, you can choose hidden. It depends on your particular situation, what you're trying to do. If you're trying to make a prefab that will merge or be harmoniously integrated with other parts of your scene, you'll usually want the normal context. Sometimes you want the gray context, and sometimes you would just want to hide everything else and isolate your object like this. But let's keep the normal context. Now our coin mesh is here. Let's add a new script. We can add a script here and then drag and drop it to our coin, or we can just add component. If we click on add component here, at the bottom here we have new script. So if we remove the text in the search bar, we have the components organized by categories. As for our own scripts, they will be displayed here in the scripts category. Right now, let's create a new script. If we hit new script and choose a name for this script, let's call it coin Animator and hit create and add. It will ask me where do I need to save the script. Let's save it in the scripts folder. Save. Now let's go to the scripts folder. If you want to edit the script, you have also two options. You can either double click on it on the project view, or you can click on these three dots here, then edit script, or even double click on the name of the script. If you click once, you will ping the script. So if you are in a different folder on the project view, and if we click here, it will ping the script and automatically show us where the script is located on the project. And we can double click on it, which will open Visual Studio. Here, let's remove all of these methods and let's add a float. So we're going to use serialize field and declare a float. Let's call it angular speed and set it to 50 by default. 50f. Now let's declare the update method, update. Now we don't want to rotate the object itself. Here in our code, if we do transform.rotation, this will in fact rotate the object itself. That's not what we want. We don't want to rotate this coin object. We want to rotate the coin mesh. So we need a reference to this coin mesh inside our script. Let's declare a transform here. We're going to use serialize field, transform. Let's call it coin mesh. And when we want to rotate, it's the coin mesh that we're going to rotate. So let's say coin mesh dot rotation. We also have the rotate method. And when I type the parentheses, I get some indications of the method signatures at my disposal. We have a method that takes a vector tree, which is basically the three values X, Y, and Z. We can type the axis, then the angle, or we can use this signature with X angle, Y angle, and Z angle. Let's use this one. I always type the semicolon at the end before even writing anything inside of the method. Let's type 0f angular speed multiplied by time dot delta time, then 0f. So we will rotate around the y-axis. Okay, now let's go back and let's save this prefab. To go back to the scene, we can either click here on the scene and let's go into the prefab again, or we can click on this arrow here to go back. Now it's showing me the gizmos at the coin mesh. That's because I have the handle position set to center. If I set it to pivot point, this is the actual pivot point, which is our empty object. Let's move this over here and let's Control D and have some coins here and there. Now if we run the game, we'll get an error message. In fact, a lot of error messages. That's because on our coin prefab, let's go into prefab mode, we didn't specify the coin mesh. We need to set it here. And here we have an error message that says the variable coin mesh of coin animator has not been assigned. And this is true. We are trying to access the rotate method on coin mesh while it's not assigned. If something is not assigned in C#, especially if it's an object here, an object of type transform, the value is null by default. We might as well say equals null. This is the value that it will have by default. Okay, let's go back. So we need to assign the coin mesh on the inspector. And for this, we simply need to drag and drop our coin mesh object to this field. And now it's set. Now, if I click here, this will ping the coin mesh on the hierarchy so we can see where it is. All right, now this is done. Let's clear the console of these error messages and let's save the prefab and go back to the scene. Now all the other prefab instances will be updated with this information. Every prefab instance, if you click on coin mesh, it will point to its own coin mesh. And for this one, let's click here. And that's what's great about prefabs. Now let's run the game. You can see that all the coins are rotating, and these values, although we have defined them on the prefab, they will have this value by default, but nothing prevents us from changing the value per instance. For example, here, if we want this instance to have a value of 300, while the other instances still have a value of 50, that's perfectly doable. Each instance has values independent from the other instances, especially when you run the game and change the values. Now, a value of 300, it seems, is a bit more appropriate for the coin, but maybe it's a bit too fast. Let's set it to 200, maybe a little faster, 250. Yeah, this is great. So let's go back, and here, if we want to set 250 for all the prefabs in the scene and all across the project, what we can do is we can either go into prefab mode. So let's go into prefab mode and let's change this to 250, and let's go back. It will tell me that I haven't saved. So let's save, and now we are in the scene. If we click on the other prefab instances, we can see that the angular speed has been changed to 250, but we can do it another way. We can change the value here, let's say 200, and you will notice that we have this blue line over here, and this means that we have some values that are only applied to this prefab instance, not to the prefab itself. And we can right click here and apply to prefab coin, or we can go here to overrides, then apply all. It will show us all the changes that this instance has relative to its prefab. If we click here, it will tell us that on this instance we have a value of 200, while on the original prefab we have a value of 250. We can apply all, and it will apply the value to the prefab itself and to all the other prefab instances. If we click here, all the coins will have a value of 200. Let's go to prefabs gameplay. If we click on coin, it will have a value of 200. Okay, so let's set it back to 250, and let's right click here and apply to prefab coin. We can also revert if, for example, you have made some changes to an instance and you don't like the changes, you can revert the values. If you revert, this little blue line will disappear and the value will be set back to the value on the prefab. Let's set it to 250 and right click here, apply to prefab coin. Now we want our coin mesh to move up and down. For this, we can use a sine wave. This is what a sine wave looks like. It goes up and down and up and down, and it's really smooth. If we apply a sine wave to the Y position of our coin, we'll be able to get a smooth up and down movement. Let's go back to our script. Let's click here, or you can also right click and edit script. Let's comment out this rotation code just so we can focus on the up and down movement. To move a transform up and down, you can say coin mesh, which is our transform. Now we want to change the position of the coin mesh along the Y axis, but we have two choices. We can either change the position in the world or in the local space of its parent, and it's usually a good idea to change in the local space of the parent. For example, if we say coin mesh.position equals new vector tree 0, 0, 0, and by the way, this is how we define positions. Positions are defined as vector trees. A vector tree is an object that combines the tree coordinates x, y, and z. If we do it like this, what we're going to have, let's run our game. We're doing it in the update method. So when we run the game, we'll get something like this, all the coin meshes. So here we have our coin. This is our first coin, it's here. Our second coin is here, our third coin is here, but the coin mesh is at 0, 0, 0. Here on the inspector it says -4, -2.58, but this is the local position in the local space of the parent, but in fact the global position is at 0. Even if I move my coin, the coin mesh will stay at 0. However, if we do, instead of position, if we do local position, now let's run the game. As you see here, the coin meshes are at 0 position inside of their parent, and when we move the parent, they will remain at 0 in the local space of the parent. So in this case, it makes more sense to manipulate the local position to move the coin up and down rather than manipulating the global position. Okay, so let's write local position equals new vector tree. But in fact, we want to increment this local position. Incrementing a variable basically means that we add a value to that variable. We want to increment this local position by a value, new vector tree. When we write like this, plus equals, to assign a value to a variable, we use the equal sign, angular speed equal 10, for example, or 150. This is an assignment. Now, after this line, the angular speed will have a value of 150. We can also do it like this. What will happen here is the current value in angular speed will be added to 150 and will save this sum into angular speed. Now, for this syntax, we can simplify it. Instead of doing it like this, we can say plus equals 150. This is a shortcut. So let's go back to our coin mesh. We're going to say coin mesh dot local position plus equals new vector tree. We only need to manipulate the y component of the vector. So for the z component, it will be 0, and also the x component will be 0. Now for the sine wave, let's use mathf.sin. This is the sine wave. It takes an input angle in radians. You know what? To keep this a little bit more organized, let's declare a variable here. Float y equals to mathf.sin, and let's use it here, y, or perhaps let's rename it. In Visual Studio, you can rename a variable by clicking on the variable and hitting F2, and let's call it delta y and hit enter, and this will automatically rename all the instances where you use that variable, which is very useful. Now we need to define the movement amplitude, which is the max distance that the coin will move up and down. Let's define it here. Serialize field, float. Let's call it vertical movement amplitude, and let's set it to 0.5 by default, and we're going to use it here. Vertical movement amplitude multiplied by mathf sin, and here we're going to use a frequency variable. Let's just copy this and paste it. Float vertical movement, let's call it frequency, and let's set it to 1. I don't know exactly what value will look good. We'll have to test in the Unity editor. And you know what? These are too long. Why don't we just call it movement amplitude and movement frequency? Okay, movement amplitude multiplied by mathf sine, and we're going to use movement frequency multiplied by delta time. Delta time. Whenever I say delta time, I mean time dot delta time. Let's test these values. Okay, we're going to see how this coin right here, how it moves. Let's run the game. Okay, it's moving up, and yeah, they're floating away. They don't seem to be coming back. What we actually need to do is, instead of using plus equals here, instead of using plus equals on the local position, we need to set the local position to something. Let's create a new float here, float coin height. Let's set it to 0.7f by default. And here, instead of doing this, we're going to set the local position directly to vector3.up multiplied by coin height plus this value computed with the sine wave. And this is equivalent to saying new vector3 0 coin height 0. We are multiplying vector3 up, which is a constant equal to 0, 1, 0. If we multiply this vector with coin height, we'll get 0 coin height 0, as I said. So it's just a shortcut instead of writing this, which is a bit longer. Or what we can do is simply this. We can say equals new vector3 0 coin height plus delta y 0. This should work better. Now let's run the game. And the frequency is basically the speed of the movement. The coin is completely still for now. Let's modify the frequency. Perhaps we need to have a smaller value, like 0.5, for example. I can see that the coin is moving a little bit. Let's increase the amplitude of the movement to 1. And let's increase the frequency, perhaps 0.6. Let's increase the frequency to 20, for example. Okay, I clearly made a mistake here when using the sine wave. If we look for the sine wave online, basically, if we give it delta time or a value multiplied by delta time, it will stay in these first angles and will never go forward. So in fact, we shouldn't use the delta time. We need to use the time value. And here, the time class also provides us the time value. So we can use delta time or we can use time. And time is, if we hover over it, it's the time at the beginning of the current frame in seconds since the start of the application. So when you start the game, this time will increase. It is a number of seconds. If you've been playing the game for 1 minute, this value will be equal to 60. If you play the game for 1 hour, it will be equal to 3600 and so on. This should fix the problem and we should have a working code right now. Let's run the game. Okay, now it works finally. But obviously the amplitude of movement is a little bit big. Let's set it to 0.2 and even that is too big. 0.1 perhaps, or let's keep it at 0.2 and let's change the frequency, perhaps frequency of 2 will make the coin move faster. Now if we go out of play mode, we will lose these values. So what I can do is right click here, copy component, then go out of play mode. Then I can right click here, paste component values. And now we have the values that we had in play mode. I'm going to go here to overrides, then apply all the overrides to the prefab. That way, all the coins will have the same values in the coin animator component. Now we can go back to our code and I can finally, we can uncomment the rotation and have the full movement here. And we can add some comments here. Let's add a comment here, rotating the coin. And here let's add another comment, moving the coin up and down using a sine wave. These comments are great because if we go back to the project a few weeks or a few months from today, just by reading these lines, we can understand what this code does. Okay, let's run the game again. Now we have a combined movement of moving up and down and rotation. I'm not really convinced by the frequency. Perhaps we need a bigger frequency. Let's set it to 3. Maybe we need even more speed, even more frequency. Let's set it to 4. Okay, this looks more dynamic. I like it. All right. Again, let's copy component and right click, paste component values. You have to watch out not to click on paste component as new, because if you do this, you will create another component here. That's not what we want. We just want to paste the values. Okay, we've applied the values. Let's run the game again. All right, this looks better. Let's fix a small problem here with the shadows. Let's go to the project settings. Then let's go to graphics, and I'm going to double click on default render pipeline. If we go to lighting, and here down here we have shadows, we can set the max distance that the shadows are visible. Let's set it to 100. And here, these problems, so these little empty areas in the shadows that you can see, these are easily fixed by setting the normal bias to 0. This fixes the problem. Okay, now we have better looking shadows. Let's go out of play mode. This lecture was a practical example of everything we saw in the last lecture. We are starting to write code. We've been able to create a coin animator script that takes control of a transform, which is the coin mesh, and we're able to rotate it over time and also move it up and down using a sine wave. It's important to remember that a sine wave needs to take the actual time, not just the delta time, which is very small. I don't know why, but I always forget this little detail. But that is game development. It's not simple, but again, it's not hard. You just have to take care of a lot of things and use a little bit of investigation. When things don't work as you expect them to, you need to investigate a little bit and find the source of the problem. Okay, let's see how we can handle input. In Unity, we used to have one way of handling input. We used the input class in the Unity engine namespace, but now we have something that a lot of people consider as a new thing, but it's been here for years. I'm talking about the input package. If we go to Window, Package Management, Package Manager. On the project, we have the input system here, and it will be installed in your project by default if you're using Unity 6 or later versions. We already have the input system, and one of the classes in the input system that's very useful is called the player input class. Let's click on our player and let's add a new component. We can go down here to input, and here we have the player input class. The player input class will point to a set of actions. If we click here, we're going to ping the actions. Our actions are defined here, and we can edit them in the project settings window. Here we have all the actions that your player can do. You can add your own. We already have some default actions here. We have move, look, attack, interact, crouch, jump. Basically, these are the usual actions that you find in action games. Let's unfold some actions. The move action is of type value. We have 3 types: value, button, and pass-through. The control type is set to vector2. If you don't understand what this means, it's okay. We're going to use a few actions, and with time you will understand what each type does. Let's try to get a button, for example, the crouch button. Crouch is a button here. Let's go to our player, and here in the player input, let's change the behavior to invoke Unity event. And by doing so, we have this fold out here. We can open it. And here for each input event, for example, if we unfold the player actions, we have for every action, we can add some methods here that will handle that action. Now we need to write a class with some methods, and that class needs to be a mono behavior as well in order to add it to the components here. Let's go to scripts. Let's create a new class here. Let's right click, create, then mono behavior script. Let's call our class player. Let's go to the player prefab and let's add our player script here. So I'm going to drag and drop this script here. Or we can click on add component, then go down here to scripts. You can also use the search bar here. And here we will find our scripts because we don't have a namespace. We're not putting them in a namespace, so they are in the global namespace here. But if we did put them in a namespace, we'll find that namespace here, and we can click on it to have a list of all the classes on that namespace. Let's click on our player here, and we've added the player script. Now let's edit it. Edit script. Let's remove the methods. And here I want to use the input package. So let's write using Unity Engine.input system. This is the namespace of the input system. On our player class, let's create a public method, public void. Let's call it say something. And it has a specific signature because that's what's required by the input system. The signature is void. It will not return anything, and it will have one parameter. The parameter is of type inputAction.callback context, and let's give it name context. When you declare a method like this, it will expect a parameter of this type. So when you call this method say something, you can't just do it like this. You have to give it something between these parentheses, but we're not going to do this ourselves. It's the input system that's going to call our methods. Here, let's just print something on the console. And remember, for printing on the console, we're using debug.log. Let's say hello world, okay? And that's it for our player script. Let's go back to Unity. Now, what we can do is unfold these events. Let's unfold the player events. Let's open the project properties. Each action is usually bound to a key on the keyboard or a button on a gamepad. Let's look at the attack action. It's bound to button west on the gamepad, to the left mouse button on the mouse, and it's also bound to touchscreen, joystick, XR controller, and the enter key. So let's use the attack action now on our script on player input, which is not our script technically, it's a script from the input system. Let's look for the attack action. Now let's click this plus button here. Now we're going to add our method here. So we're going to drag and drop our player object. Let's drop it here. Then we're going to look for our method. Let's click here, then look in player. And in player, we have the list of all the methods that we have. This is our method, but these methods are methods that we have inherited from mono behavior. Now let's call our say something method, okay? Every time we perform this action, either by triggering any of the controls here, we are going to call player.saySomething. Let's open the console and run the game. I've clicked on the left mouse button on the mouse. By clicking on the left mouse button on our mouse, we get these three events. And the reason why it's called 3 times is because each action goes through 3 phases. It starts, then it's performed, then it's cancelled when the button is up. In our code, we need to only perform this action when the context has been performed. So we'll use an if statement, and we can write it like so. If, then we write a condition between these 2 parentheses. If context dot performed, and performed is a Boolean property. If context is performed equals true, only then are we going to do a debug log hello world. About the syntax here for the if statement, we're writing a condition between 2 parentheses, and here the condition is that performed is true, and we use 2 equal signs to express that we are doing a comparison. Earlier we said that to assign a value to a variable we use 1 equal sign, but for comparison we use 2 equal signs. If this is true, we are going to execute all the code inside of this block defined by these 2 curly braces, and inside of the code block we have our debug log hello world, and this will allow us to only execute the action once, not 3 times. But sometimes it's useful to know when the context has been cancelled, which means that the button is up, so we can perform something when the button is down, and we can perform another thing when the button is up. All right, this should do. Let's save our scripts and go back to Unity, and let's run the game now. Let's click somewhere. Now we only get 1 message on the console. Let's click again. I'm going to hold the mouse button, and now I'm releasing it. Let's go back to our script. By the way, this is optional. A Boolean value can itself be used as a condition. Saying equals true is optional. The compiler will understand the code if we just write it like this, but you can keep this for the sake of clarity if you want. Let's add an else statement. So when you have an if condition, this code block will execute only if the condition is true. Otherwise, if the condition is false, we can write an else statement here and write what will happen in the case that this condition is false. Let's write debug log. Something else happened. Let's go back to Unity and run our game. I'm going to click and it said something else happened and hello world. Because we've started the action, we have performed it, and I'm still holding the mouse button, by the way. I'm going to release it and now it's going to say something else happened. Let's make these messages more specific. Let's go back to the code. We can write multiple levels of else and if. Here, for example, if this condition is false, we can add another if statement here, else if context dot started, and let's add an else if here, else if context dot cancelled, and let's write another debug log here. Let's say in this case, let's say the action has started, and here let's say the action has been cancelled. Okay, let's save and go back to Unity and run our game. I'm going to click and it's going to say the action has started. Then hello world. Then I'm going to release the mouse button and it's going to say the action has been cancelled. As I said, this is very useful in case you want to do something specific in your game, depending on whether the player has released a button or pressed it for the first time. Now let's handle this move action. While attack is a button, this move is a value of type vector2. Let's go back to our script and we're going to define another method. Public void, let's call it onMove, is going to have the same signature of this method. About these signatures, you don't have to understand why. This is how the Unity engine has been designed. They have decided, the people who developed Unity have decided that this is the signature of the method. This is how it is. And by writing them over and over again, you'll get used to it and it will become muscle memory. So don't worry if you don't understand something in the code, just write it down over and over again. With time, it will stick. And even the things that you don't understand, the fact that you will write them over and over again and memorize them, then one day when you read something or see a YouTube video, for example, then something will click and you will understand what it means. So just go with the flow, even if you don't understand how things are working. We have our onMove method. Now we need to get the value inside of our action. So we're going to say context read value, and we need to define the type of that value. We define the type between these angle brackets. Since the action is of type vector2, we need to say vector2. A vector2 is like vector3, except it works in 2D. In here, we only have access to the X and Y component. Once we read this value, we need to store it somewhere. Let's store it in a vector2. Let's call the variable value. And here we need to add two parentheses because this is a method. Even if a method doesn't take any parameter or any input, you should write the parentheses even if they're empty. This tells the compiler that this is indeed a call to a method. Now let's print this value. Let's write a debug log. And this time I'm going to write a $sign before the double quotes. What this will allow me to do, you'll see in a minute. Let's write value equals. And here, if we use curly braces, we can write some code or the name of a variable inside of the curly braces. And at runtime, when we run the game, it will be replaced by the value of our value variable. And here it's a little bit confusing, a value inside a variable called value. And this is in fact the same thing as doing debug log value equals plus value. This is pretty much the same result, but I prefer to do it this way. So the console will write this, and here we can write anything we want. There's nothing special about this. Let's say, hey guys, my value is, for example. You can write anything you want. This will be printed as is, but for our value here, it will be replaced by the value inside, okay? Now let's go back to Unity. It's not enough to define the onMove method. We still have to use it inside of player input. So let's enfold the events and let's go to player and let's go to move and let's add another callback. We can simply add any component on the player object. It's fine. Let's look for player and the onMove method here. All right, that's it. We're done. Now let's run the game. I'm going to wait for it to load. I just want to see, yes, the move action is bound to WASD. Like in most FPS, TPS games, or any action game, it's bound to the left stick on the gamepad and other controls. Here, if I hit WASD, for example, I'm going to press D. It's going to say my value is 1, 1, 0. If I don't press anything, it will say 0, 0. And if I hit A, it will say -1. If I hit W, it will say 0, 1. And if I hit S, it will say 0, -1. This seems to be working. Now let's go back to the code and we can just delete these debug logs. We don't need them anymore. Okay, we don't need this method anymore. And in fact, we're going to write the rest of the methods. Public void on attack, and we're going to use the same signature. Okay, let's connect our on attack method with the attack action. Let's open the events on our player input and then let's go to player. And here, since we deleted the method say something, is going to say missing player.saySomething. So it has recognized that the method no longer exists. And by clicking here, we can go to player, then rebind it to on attack. All right. So we have the on move action and the on attack actions ready to go. They are bound to our script. All right. Let's recap what we've learned today. We saw that variables are not exactly containers. They can also be shortcuts or references. If you want to use the technical terms, they are references to other variables, or I should say they can be references. If the variable is of a class type, we can definitely use it as a reference. And we've seen an example here of our coin mesh. This is indeed not the value of the coin mesh transform, but it's just a shortcut to that value. And finally, we saw the player input component and the input actions in each Unity project using the input system. We can have project-wide input actions defined by this file over here. Our actions are within this file, and to edit the actions in this file, we can go to project settings. Here you can see again a reference to the file and the actions within that file. We already have a lot of actions to work with. Unity provides us with all of these actions, but we can add actions of our own and we can bind them to something. And using the player input component here, and especially when we set the behavior to invoke Unity events, we have access to these events here, and we can simply create a callback here and bind it to a method on one of our scripts. It doesn't matter. We just have to look for the method here through this drop-down list, and we can use pretty much any method on our scripts. Now, to handle input, we are using Unity Engine.input system, and for methods that are going to be bound to the input events, we define them with this signature public void onMove, or the name of your method, with this parameter of type inputAction.callback context. In this lecture, we're going to see how to handle the movement input and use it to move our character. Let's go to our character. Let's click on our player object. On here, we have the player input component and we have our player component. On the left of the inspector, you can see these blue lines all across our components. And if the blue line covers the header of the component that displays the component name, it means that this component is specific to this prefab instance and is not present on the prefab itself. And to solve this, we're going to override the prefab. Let's click on this override drop-down button here. Then let's apply all. And now the blue lines have disappeared, which means that all of these components are also present on the player prefab. We can click select here to ping the prefab. In case you want to select the prefab in the project view, let's hit select. And this has both pinged the prefab, and by pinging I mean that the project window has navigated to our player prefab and it has selected it. With the prefab selected, you can see that the player input and player are present on our prefab. Let's open our player script. Here we have two methods to handle input. In Visual Studio and in a lot of other editors, we can create regions. All you have to do is type hashtag region and then hashtag end region. We can put our code in here. So I'm going to Control X. Then I'm going to put the code inside of this region and I can give it a name. Let's call it input handling methods. And the great thing about regions is we can collapse them. Here with the region collapsed, I can fold it or unfold it to keep our file well organized. Now I usually also create a region for Unity callbacks. This is where I'll create my start method and my update method. Let's add an update method here. In the onMove method, we are getting a vector2 value. Now let's store this value somewhere. Let's fold this region. We're going to create a few fields here. Let's have a private vector2 and let's call it move input. In our input handling method, we're going to set our move input to this value. No need to declare a variable here. We can directly say move input equals context.readValue. Now this move input variable will be updated every frame with our movement input value. Now in the update method, what we're going to do is we're going to increment the position of our transform. Remember that we have access to our transform. Since we are inheriting from mono behavior, we have access to transform dot position plus equals, let's say, move input multiplied by a value, and usually this is your speed. Let's define it here. Private float speed. Let's set it to 10 meters per second and let's serialize it in order to display it on the inspector. Remember that to do this, we need to add a serialize field attribute. Now we're going to multiply our move input with the speed. We also need to multiply by a value of time, or I should say delta time, since the delta position, which means the position that our character can move during this frame, is going to be equal to speed multiplied by time, since speed is already a distance divided by a time. So we need to multiply speed by delta time, and we get it through the time class in Unity. Now we have an error here. It says the operator plus equals is ambiguous on operands of type vector3 and vector2. And this is right because move input is a vector2 and the transform that position is a vector3. So it's a little bit ambiguous. Let's use another variable here. Let's declare it as a vector3. Let's call it move input 3D equals new vector3, and we're going to set the x value to move input dot x and the y value we're going to set it to 0, and for the z value we're going to set it to move input dot y. Remember that the x and z axes are what makes the vertical plane. We don't want to move up and down. That's why we'll keep move input on the y-axis to 0. Now we're going to use our move input 3D here, and this should increment our position every frame. Now let's go back to Unity and test this. Let's click on our player. Here we have our speed float. It's set to 10, but we'll see if this is enough. Let's run the game. I'm going to press WASD. Okay, now my character is moving. I can move right or left. I can move up or down. And remember when I said in the beginning of the course that it was easier for us to have the camera point to the same direction. If we go here to the local mode, we can see that the z-axis points forward in this direction, which is also the direction of the space or the global space. If the camera was on the other side and was looking this way, we would have a little bit of a problem because if we move the character left and right, it would actually move in the opposite direction. So we're making it easier for us, but as the course progresses, we will see ways to solve this problem no matter which direction the camera is pointing at. Then we will handle the input properly. For me, a speed of 10 is a little bit excessive. Let's go back to the player and let's reduce it perhaps to 5. This is still a bit much. Let's say 3.5, for example. Okay, this is more reasonable. Let's go out of play mode, and here, as you can see, the value of speed has been reset to 10. Now let's set it to 3.5 and let's right click and apply to prefab. If you have noticed, the character is moving, and of course the camera is not moving. We don't have a script to control the camera yet, but the most important aspect of this is our character is not colliding with our obstacles as we want it to be. Let's see here from the scene view. We want these obstacles to block the path of the player. That's why we lay them out this way, so the player will not be able to leave the arena. But here if I go right, I'm perfectly able to go through the obstacles even though they have a collider on them. That's because we're setting the position of the transform of the player. We're basically forcing the transform to be at that position, and there is nothing preventing the player from colliding with these obstacles. Instead of handling this ourselves, we can add a component made by Unity, and it's called a character controller. Let's add a character controller to our character, and let's zoom in on it. The character controller has a capsule. As you can see here, the capsule is way too big. So we need to resize it to fit our character. Let's set the radius to 0.3. And for the height, this is way too big. Let's set the height to 1. And we need it to go up. If we run the game right now, our character will be standing in the air like this. We don't want this to happen. So what we can do is set the Y component of the center to half the height. Let's set it to 0.5. And this should fix the problem. Now let's go to our player script. We need a reference to the character controller. Remember what I said in the previous lecture? We can have variables reference other objects somewhere else. A variable does not necessarily need to have a value within itself. Let's go to our player script. Let's go up, and here we're going to add a reference to a character controller, and we need it to be exposed in the inspector. So let's add a serialized field and let's declare a variable of type character controller, and we can name it character controller even if the name of the variable is the same as the name of the class. It's okay. The compiler is smart enough to understand this. Now that we have a character controller, let's go to our update method. Instead of forcing, that's what we're doing here. We're basically forcing the transform to be at this position. Instead of doing this, let's comment this out. What we're going to do is call a method move on the character controller. We have a move method, and here in the documentation we can see that the move method takes a motion. A motion is basically a delta position. Let's set it to this value. I'm going to copy this and paste it here in the move method, and don't forget the semicolon at the end. All right, let's save our script. Now let's go back to our character. Here you can see that our character controller variable doesn't point to anything. So its value is null and it displays an empty field here. What we'll do is set this value by dragging and dropping the character controller onto this field. Okay. Now this variable is pointing to our character controller component, and this should do it. Let's save and run the game. Now let's move our character. Our character is moving with the move method, and as you can see here, they can't collide with obstacles, but we have a tiny issue. Is our character has climbed over the obstacles. What we can do here to solve the issue and prevent our character from climbing over obstacles is either playing with the values here. Let's play with the step offset, or we can simply have our colliders be very tall on our objects. Let's start by trying the step offset. We have a step offset of 0.3. In the Unity documentation, the step offset is the maximum height in meters that the character can climb over automatically when moving. And here it says that lower values make the character collide with even small obstacles, potentially requiring jumping or custom logic to overcome them. This is exactly what we want. Let's see how low we can set the value. Let's try 0 and let's test it. Okay, this seems to be working. Our character is no longer able to climb these obstacles. This is the exact behavior that we want. Now the character controller is a little bit weird in its behavior. Sometimes if you have your character at 0 on the y-axis and it's directly touching the ground, if you run the game, the character may bounce a little bit. Here it didn't do it, but sometimes it bounces upwards a little bit and your character may look like it's hovering a little bit above the ground. Since the character controller doesn't have a simulation for gravity, there is nothing that can bring your character down. If we do it like this, our character will hover over the ground like it's levitating in the air and nothing can bring it down. If that happens to you, then you can simply set your capsule a little bit above the ground, something like this, and it should do it. But I believe we should implement something that would bring our character down, a gravity force. And this brings me to my next point. In Unity, we have like 3 ways that we can create characters. The first way is what we saw earlier, where we directly set the values of position on our transform. This is the custom way that you can do it. The second way is by using a character controller. And the character controller, sure, it doesn't have simulation of gravity and it lacks a lot of things, but on the other hand, it's very flexible. It allows us to implement some incredible movements. And the third way that you can do it is by adding a rigid body. Instead of the character controller, we add a rigid body. And now our character is completely handled by physics. We can apply forces to the rigid body and do all sorts of things. On YouTube, you will find a lot of tutorials of character controller scripts that use a rigid body. I personally don't like that approach. I prefer the customizability that the character controller can give us, especially for characters. So all we have to do now is perhaps implement gravity and perhaps also a little bit of jumping. Why not? If we go to the project settings, let's go to edit project settings, and I have docked them right here. If we go to physics, then settings, here we have a vector tree that represents gravity, and we can actually access this vector in our code. Let's go to our player script. Let's edit the script. Now, instead of setting the motion here to 0, now let's organize this code a little bit. We're going to remove this line and let's have this as a variable. Let's call it vector tree motion and let's set it to this value. And we're going to move with this motion here. But before we do that, here we need to apply the gravity. For this, we need to keep track of our vertical velocity because we need to accelerate every frame towards the ground. And we need to keep track of the accumulated velocity that we have. Let's go to the top and let's create a new private float. Let's call it vertical velocity. And let's set it to 0. In the update method, what we're going to do is we're going to increment vertical velocity by physics.gravity.y. This will be equal to minus 9.81, I guess. Yeah, this is the value that we have in our physics settings. And this physics class is also provided by Unity. And here we have the vector tree gravity, which is a static vector. Now we need to multiply by delta time. This way we'll get the speed change this frame, and we're going to accumulate that in our vertical velocity. Now, if we do this while being on the ground, this vertical velocity will keep getting in the negative values and will keep getting bigger in the negative values, and we don't want that to happen. We want to stop it at a certain point when we are on the ground, and thankfully on the character controller component we have a boolean that tells us whether we are on the ground or not. Let's add an if statement here. If character controller is grounded, we have the is grounded boolean, and this is enough for our condition. If character controller is grounded, then we're going to set vertical velocity to a negative value like -3. This will keep it at -3 at all times when we are grounded, and only when we are in the air will we increment the vertical velocity. So let's add an else statement here, else, and I'm going to paste the line that we had at the top. Okay, if we are grounded, we'll keep vertical velocity at -3, and if we are in the air, for example, if we jump in, we will increment the vertical velocity by this value every frame. Now, the last step that we need to do is set motion.y to vertical velocity multiplied by delta time. That way we get the motion on the y-axis as well. Okay, let's go back to Unity and we're going to test our gravity code. Let's set the player somewhere over here and we're going to start the game, and we're going to see our character fall to the ground. Okay, when we move the character up, the character falls down again to the ground. Now, in order to view the vertical velocity, we can actually see the values of private fields. Let's click here on the 3 dots and enable debugging on the inspector. And now on our player script, we can see the vertical velocity. As long as we are grounded, it's kept at -3. And if we are above the ground, you can see that it's accumulating some values. And we can also see the move input here on the game window. If I hit WASD, we can see that the move input variable is changing. And what's great about it is that the vector is normalized. And if you're familiar with vectors in mathematics, it means that the length of the move input vector is always kept at 1. Otherwise, the diagonal movement of the character will be faster than the orthogonal movements. Moving up and down, left and right will be slower than moving diagonally. And this was a problem in older games. And the solution is simple, is that you have to normalize the movement input. But apparently Unity already does it. We don't need to do it. Okay, now let's add some jumping. We have a simple formula that we can use for jumping. It goes like this. V equals the square root of 2hg, where V is the vertical velocity and h is the height that we want to jump, and g is the absolute value of the gravity. Now we have to define the height of the jump. Let's say this is our character. Our character is standing on the floor. If we wanted to jump in the air, this is the h distance that we wanted to jump. Okay, we already have the value of gravity and we can define the value of h. We can set it as a variable on our script that's exposed in the inspector, so we can change it. And here, using this formula, we can compute the vertical velocity that we need. Let's start by handling jump input. Let's have all our input variables here. Private bool, jump input. And let's go to our input handling methods region. And here we need another method, public void on jump. Input action, callback context, the same signature. Let's set our jump input to context performed. Let me remind you that when we have a button, we have 3 steps in handling the input. The action can be started, then performed, then cancelled. We'll only set jump input to true when the context is performed, when the action is performed. Now let's collapse this region and go back to our script. Before we set the vertical velocity, let's write a comment here, handling the jumping, or let's say just jumping. If we have jump input, this frame, what we can do is set our vertical velocity to the square root of 2hg, and we can get the square root using mathf mathf.sqrt. This is the square root method provided by Unity in the mathf class. And here, let's say 2f multiplied by jump height. We'll define this later, don't worry about it. Multiplied by, let's get the absolute value of gravity, mathf.abs. This is another method that gives us the absolute value of a number, mathf.abs of physics.gravity.y. Now all we need to do is define this jump height. Let's go to the top and below the speed, let's say serialize field, private float jump height. Let's set it to, we don't want our character to jump very far. Let's say 1 meter in the air is fine. Okay, let's go back to the update method. Now we don't have compilation errors anymore. Let's go back to Unity and let's reset our inspector to the normal mode. We need to connect our action here. Let's go to events, then player, then let's look for jump. This is it, jump. And we can drag and drop our player here from the hierarchy. Then we're going to look for the onJump method. Here it is. Okay, let's collapse this player input and we have all the parameters set. Now let's test it. We're going to play the game. Our character is on the floor. We're going to hit space to jump. And our character has jumped. And it will be able to jump over obstacles. Now I don't like the fact that the character takes so long to jump and come back down to the ground. What we can do is apply a gravity scale. Let's open our script and let's go up here. Let's add another float. Let's just copy this one so we can do it quickly. Let's say gravity scale and let's set it to 2 or 3 by default. By the way, the values that we set here don't matter because the values that will be stored in the objects in your inspector and on the prefabs will be defined by Unity. These are just the values that will be set the first time you add this script to the object. And since we've already added the player component to our object, setting values here doesn't matter, although gravity scale is a new value. So when Unity compiles this script, it will add the gravity scale to the inspector with this value. But beyond that, these values almost don't matter for the rest of the lifetime of the project. Okay, now time to apply the gravity scale. Okay, let's go back to our update method. Now when we increment the vertical velocity, we want to apply the gravity scale. And also when we apply the jumping force, we want to apply gravity scale here. So let's multiply our physics gravity.y by gravity scale. That way the gravity scale will be applied. We'll basically apply twice or 3 times the amount of gravity in order to make jumping and falling back to the ground more snappy. If you want, you can go to the project settings and modify the gravity on the whole project, but this is usually a very drastic solution. Let's keep the gravity as it is. This is gravity on Earth. For other objects that may be subject to gravity, it's completely fine, but on our player, we want something more snappy. That's why we add this gravity scale. Okay, Unity has apparently compiled our script and we have a gravity scale here set to 2 by default. Let's run the game. Okay, we're going to maximize this. And by the way, if we go out of play mode, you can choose from this drop-down menu here to always play maximized. Whenever you hit the play button, the game view will maximize itself by default. Sometimes you want this as a default behavior, sometimes not. So this is a gravity scale set to 2. Let's try a value of 3. Let's try gravity scale 3 and let's maximize this and jump. Okay. So jumping is way more snappy and also falling back to the ground. Let's try a bigger value. Let's try 5. Okay. We have a slight problem here. It looks like our character has a jetpack. If I hold the space bar, my character will keep rising up. Yeah, he definitely has a jetpack under that Roman armor. All right. Let's fix this problem. This should not happen. But a gravity scale of 5, yeah, it looks snappy enough. So let's set it. Now we're out of play mode. Let's set it to 5. And I'm going to apply the overrides to the player prefab. Okay, we have a small bug on our hands. Let's try to solve it. It's great that we're encountering these bugs, so I can show you how to solve them. Your ability to investigate these small issues and even bigger bugs is almost as valuable as getting it right the first time. Because, I mean, honestly, no one gets it right the first time. Don't worry about it. Just keep investigating, keep trying to understand what happens. Right now we are in the update method on our player script. We need another condition here. We not only need to check if jump input is true, but we also need to check if we are on the ground. We can only apply this change to the vertical velocity if we are on the ground. So here in our condition, let's add another condition, and to express that, we can use 2 ampersand symbols. This will express and. We need jump input to be true and character controller that is grounded to also be true. So let's type it here, or let's copy from this code here, character controller that is grounded. So we need both of these to be true in order for the whole condition to be true. And this should fix the issue. We should not apply this change to velocity if we are in the air, even though the jump input is true. Now let's go back to Unity and let's run the game. Now I'm going to press the space bar and try to hold it. Okay, as long as I hold the space bar, the jump input will be true because it's tied to the performed Boolean on our action. Let's go back to our code. What we can do here is, instead of doing it like this, directly assigning the value of context.performed to our jump input. We don't want jump input to go back to false. Let's say if context.performed, then we're going to set jump input to true. And down here in the update method, as soon as we have jumped, let's set jump input back to false. Now we have solved the problem. I can press space and our character will only jump again when we press space again. And we should not be able to jump over these obstacles. What we can do here is perhaps increase the height of the collider on these obstacles. Let's click on this object and let's go here to edit collider. Let's click on this button and I can simply drag on one of these points to make the collider way higher. All right, now let's apply these changes. Let's click on overrides, then apply all. That way all the prefab instances of this obstacle will have the same collider. And perhaps here, to add more variety to the level, why don't we rotate these a little bit, something like this. Now we should be able to jump, but let's change perhaps the parameters of the jump. For the jump height, let's keep it at 0.5, and for the gravity scale, let's keep it at 3. I believe these values, yeah, these values look better. So here for the rocks, or the, I don't know what these are, bricks, we can't climb over them anymore. Now we have a final detail that we need to take care of. Our character needs to look in the direction where we are moving. Let's go back to our code. We can use this move input 3D to determine the rotation of the character. Let's do it in a method. Let's write a new method here, or perhaps down here. The return value, we want it to be a float. It will return an angle. Let's call it get angle from vector. And let's have a vector3 direction as parameter. This movement vector, move input 3D, is the direction in which we are moving. And to get the angle that we want the player to be pointing at, let's use a method in quaternion. Quaternion.look rotation, and we're going to give it our direction, and the up vector is going to be vector3 up. This is the signature of the method. So it takes the forward vector and it takes the upward vector, and it returns a quaternion of that rotation, and that's exactly what we're going to give it. Vector tree dot up. This is the up vector of the world, and we're going to store this rotation in a variable. Let's declare it here. Quaternion rotation equals this value. Now we're going to extract the y component of this rotation, and we're going to return it. In order to return a value from a method, we use the return keyword, return rotation dot Euler or Euler angles dot y, and this is the angle that we want our character to point at. Let's go back to our update method, and you know what, we can do this in a method as well. Let's create a method here. We don't need this method to return anything, so we're going to type void. Let's call it update player rotation, and let's give it a vector tree move input, and we're going to use our method here, get angle from vector. So we're going to get the angle from move input, and we're going to store it in a float. Float angle equals get angle from vector, and we're going to set transform dot rotation dot Euler angles dot y equals angle. We can do something like this, transform that rotation that Euler angles that y, but this is not possible because, as it says here, cannot modify the return value of quaternion dot Euler angles because it is not a variable. And what this error message means is we can read the value of the y component on our rotation, but we cannot set it like this. What we're going to do is we're going to get the Euler angles of our rotation using transform.rotation.Euler angles. So we have declared a vector tree player rotation, and what we can do is set player rotation.y to this value. Here no need to declare the angle variable. Let's set it to get angle from vector move input, and we can remove this line. Now let's set the rotation of our character. What we can do is set transform.rotation to quaternion.Euler, and we're going to give it our player rotation. All right, that way we transform player rotation back to a quaternion and feed it to our transform rotation. Now let's use this method, perhaps over here. Let's use it, update player rotation, and we're going to give it move input 3D. And now let's test this. Our character is looking in the direction of input, but when input is 0, you can see that the rotation of the character is being reset. We don't want this to happen. What we need to do is, if the player input or the move input more specifically is close to 0, we don't need to do anything. We don't need to apply the rotation. And here on the console, we can see that we get these messages. These are not error messages, but they're more like warnings. Even though they're not warnings, technically speaking, they say look, rotation viewing vector is 0. Let's go back to the code. We can quickly enter the definition of a method by holding Control and clicking in Visual Studio. Okay, now we are in the definition of the method. Here what we can do at the very start, we're going to check whether the magnitude of this vector is close to 0, and we can do this with an if statement. If move input dot, if we use capital M, this is the move input that's declared on our class. We don't want to use that. We want to use this instead. If move input dot magnitude, we can check both the magnitude or the square magnitude. In programming, the square root operation is quite costly if you're doing it every frame. In some cases, it can hurt performance a little bit, but not so much. It's not like a huge problem. But here, if we want to check if something is close to 0, checking the magnitude or the square magnitude is almost the same thing. So let's check the square magnitude instead. Because this vector tree is made of floats, we can't really check if it's equal to 0. This will not give us an accurate result. Instead, when you want to compare a float value with 0, what you can do is say that if this or the square magnitude of the vector tree is lower than a very small number like 0.01, if it's lower than this number, then it means that it's close to 0. And in this case, we don't want to execute the rest of the lines. And since our method doesn't return anything, we can simply type return. And at this point, the method will stop here and will not execute the rest of the code. And this should fix our problem. When move input is 0, when we don't touch anything, then we will not reset the rotation of the character. Let's go back to Unity and let's run the game. Okay, we're going to move our character. And as you can see here, the rotation is not being reset. Although it doesn't work for the diagonals, we have to really release the two buttons at the same time. We can definitely make it smoother, but we'll see this a little bit later. All right, let's recap. In this lecture, we implemented player movement. We also implemented jumping and the effect of gravity on the player. And we also made the player character face the direction of movement, which is always a positive thing, a move in the right direction for our game. In this lecture, we are going to animate our character. Right now, our character is not being animated. They can move around, but we definitely need some animations. Let's see how we can do that. Let's click on our player object, and here we can add an animator. Let's click on add component, then look for animator. Let's make sure that apply root motion is disabled. Here we'll need an animation controller. Let's create that. Let's go to the content folder, and let's create a new subfolder here. Let's call it animation. In the animation folder, let's right click, create, then go to animation, then animation controller. Then let's call it Roman soldier animator. And let's open it. Let's click this open button here on the inspector. This will open the animator window. If it's not docked for you, then you can dock it anywhere you want on the UI. This is what's called a finite state machine. We have an entry state. This is the first state that our animation will be in, or I should say our character, because we're going to use multiple animations. Our character can be idle, they can be walking, running, jumping. All of these are different states. Let's go to the models folder and to the Kenny mini arena. Inside of the character model, Kenny has provided us with some animations. Let's go to character soldier, and if we go to animation, here we have a lot of animations. We have an idle animation. If we click here, then click this play button down here in the preview, we can see the idle animation playing. We can right click and move the mouse to rotate around in this little preview. We have a walk animation, a sprint animation, those will be handy, a jump, then a fall. We have crouch, sit, and a lot of useful animations. Okay, let's click on our idle animation and let's go down here. Let's make sure that loop time is checked because we want the animation to loop over time, and then hit apply. If you hit apply, apparently the first item of this list gets the focus. Since this is the static animation, let's click again on idle, and we're going to use walk. Let's make sure it also has loop time checked. Okay, and let's go to perhaps sprint, loop time, jump. We don't need it to loop, or perhaps we do. Let's check loop time, and we're going to do this for pretty much all the other animations that we want. All right, idle, walk, sprint, jump, fall, and now let's hit apply. To add an animation to our animator here, we can unfold the character soldier, which will reveal the animations. Then we can drag and drop an animation here. These items with what looks like a green triangle are our animations. Let's look for idle and let's drag and drop it to our animator. Okay, so now we have the idle animation here as the entry state. You can see that Unity has automatically created a transition between this entry node here and our idle animation, which means that idle is the first animation that is going to be played if we run the game now. But before we do, let's click on player. Yeah, I forgot to assign the controller here. So let's click on this circle and let's click on our Roman soldier animator. All right, now our controller is linked to the animator on the player character, and this will animate the character. Let's play the game and test it. Okay. Now you can see that the character is playing the idle animation. Let's go to the scene window. All right. Here you can see that the character is indeed playing the idle animation. Now to add the other animations, to add walking and sprinting and the other animations, we're going to add states here. For example, for jumping, where is jumping? Here it is. We're going to add it here. If we jump, we're going to switch to the state. But in order to do that, we need to add some parameters to our animator, because if we have a transition here, if we right click on idle and click on make transition and then click on jump, this transition needs a condition to be triggered, and we can add the condition here on the inspector of this transition. Let's click plus. Right now it says that we don't have a parameter on the controller, and that's true. We need to add a parameter here. We can either add a float, int, bool, or trigger parameter. For jumping, let's add a boolean. Let's call it jump, and we also have a falling animation, which is good. Here it is, fall. Let's drag and drop it on our animator, and for falling, let's add another boolean, fall. And for this transition, let's set the condition that jump is true. We can choose whether it's true or false, and we can uncheck has exit time, because this transition needs to work as soon as jump is set to true. Then if we transition from jump to fall, it's going to be under the condition that fall is true, right? We transition back to idle from fall when fall is false. Let's set the condition to fall and then set the value to false. All right, so we are in idle. If jump is set to true, we're going to transition here to the jump state, and then in the jump state, if the condition fall is true, we're going to transition to the fall state, and then from fall, we're going to transition back to idle when fall is false. Now in our script, we need to interact with our animator and set these parameters in the update method as the character moves around. Let's start with jumping and falling, and then we can look at walking. Let's click here, then edit script. We're going to edit our player script. This is our player script. We have the input handling methods, the Unity callbacks, and then some functions or methods down here. Let's look at the Unity callbacks. The update method is here. Now let's organize this a little bit better. Let's create a new region down here, and in Visual Studio, you can type region and then hit tab and tab again, and this will automatically create an end region line and give you the input to set the name of the region. So it's a shortcut instead of writing it manually. This is a nice shortcut. Let's call this character control methods. And let's create a method here, void update movement. And don't forget the parentheses, then the curly braces. And here we're going to copy all of this code, all the code in the update method. We're going to Control X, then here Control V. Now all the code is contained in this update movement method. This will allow us to organize our file a little bit better. Let's fold this method. And here in the update method of our mono behavior, we're going to call update movement. Now let's have another method. Let's call it update animator, and here let's define it. First, let's move these methods to the character control methods, and let's fold this region and create another region down here. Let's call it animator methods, or let's just call it other methods, because we'll have like one method to update the animator and that's it. Void update animator and parentheses and the curly braces. All right, now let's define a reference to our animator. Here we have all the fields in our class. We have a reference to the character controller here. Let's add another reference to an animator. Serialize field, animator, Let's call it Animator. To keep this organized on our inspector, let's go up here and add a header. A header property displays a small header over your variable fields in the inspector, which is very nice. Let's create a header, and it takes as a parameter the title that you want to display. Let's write component references. And now with the animator here in update animator, what we're going to do is set the values of the booleans. We have two booleans, jump and fall. So we're going to set animator dot set bool, and we're going to give it the name of our boolean. Let's just set it to true just for testing, and let's copy and paste this line, and we're going to replace fall by jump. Let's set jump to false, and actually let's have this as the first line. We just want to test if this is working. All right, in update we are calling update movement and update animator, and here, yeah, we're doing this just for testing, but we just want to see what happens. Okay, let's run our game. And of course, I always forget to set the reference. We'll get error messages here. Animator is not assigned in our player. So here you can see that the inspector displays our nice header here, and it has created some space before the header, which is really nice. It adds a touch of cleanliness to our inspector. Let's assign the animator. I'm going to drag and drop our component here. Now the animator is set. By the way, you don't have to always clear the console. It automatically clears itself on play. Let's run the game. And let's right click, maximize. With our player character selected, let's click on the animator, and I can see that it's playing the idle animation. And of course, it's not going to play fall because we have no transition from idle to fall. The only way to change the idle state is through this transition. Jump needs to be true. Okay, let's dock this animator here actually, so we can see the animator and the scene view simultaneously. If I set jump here manually, it's going to be overridden by the script. It's not going to allow me to do it. Okay, let's go back to our script. Now we need to identify when we are jumping and when we are falling. In order to do that, what we can do is we're going to check if the character is grounded. If the character controller is grounded, we're going to set jump and fall both to false. And just to keep the syntax clean, let's define two variables here. Bool jump equals false by default, and bool fall equals false. And down here, after we modify the values of jump and fall, we're going to set the values on our animator. Here we're going to set jump to jump and then fall to fall. Okay, I'm doing this because I don't want to repeat these lines over and over again. Let's just modify these variables and at the end update the animator once and for all. Okay, when we are grounded, we're going to set jump to false and then fall to false. Else, now we have two cases. When we are jumping, our vertical velocity is positive and it stays positive until it reaches 0 because it's under the effect of gravity. And then when it reaches 0, that's the peak of our jump, it starts falling back to negative values. And we're going to use that for distinguishing between jumping and falling. So let's say if vertical velocity is greater or equal to 0, then we are jumping, then jump equals true. So if vertical velocity is greater than 0, jump will be equal to true. Else, in the other case, when vertical velocity is lower than 0, then we're going to set fall to true. And I believe that's it. That's all we need to do. And at the end of this if-else statement, we are going to update our animator here. Okay, let's save and go back to Unity. And let's run the game to test this. We're playing the idle animation. I'm going to jump, then fall. Apparently it doesn't let's go to the animator. Yeah, it doesn't transition to fall for some reason. I guess it's because we have has exit time here. Let's uncheck has exit time on this transition as well. And by the way, we are in play mode and we are modifying this animator. We're not actually modifying the component on the player. We are modifying this controller, and this controller lives in the project, not in the scene. And that means even if we are in play mode and if we make changes here, they will persist even if we go out of play mode. So now, why is my character playing this animation? Let's just go out of play mode. So I'm going from idle to jump without an exit time, then from jump to fall when fall is true, then from fall to idle when fall is false. Perhaps we can debug these booleans. Let's go to the inspector of our player and let's enable debug mode. Let's click on these 3 points, then debug, and here we can see the vertical velocity. Okay, let's run the game and let's change the play maximize on the game view to play focused, because I still want to keep an eye on the values. Okay, now it seems to be working. So the problem was that perhaps we needed to go out of play mode and start again for the changes on our animator to take place. Jumping is very quick, so animations don't have enough time to play. Let's perhaps change the jump height to 0.75 and perhaps change the gravity scale to 2 just so we can see the jump a little better. Let's set the gravity scale to 0.5. Okay, so here we can see it more clearly. Now we are playing the jump animation and then the fall animation, and let's dock our animator over here. Let's zoom out just so we can see what happens. So we are in the idle, now in the jump, and now in the fall. Actually, let's keep the gravity scale at 1 and let's see what happens. Or perhaps 2. Yeah, we just have to modify the height of the different obstacles to not allow the player to jump over them. I think this gravity scale works a little bit better. Okay, let's go out and let's remember to right-click on player, copy component, then go out of play mode, then right-click, paste component values. And then let's go out of debug mode on the inspector. Okay, let's right click on the animator, then maximize. Now we have jumping and falling. They're working as we expect. As for the idle, now we have a little problem. If we add walking and sprinting and more movements here, we'll have to define the same transitions with each state. One way that we can save ourselves all of this effort is to combine idle and walking, and perhaps in the future sprinting as well, into what's called a blend tree. Let's right click here, then create state, and from blend tree, this is our blend tree. We're going to call it movement, and we're going to double click on it. Here we need a parameter to handle the blending, because we're going to blend between multiple animations, but mainly between the idle and walk animation. Let's define the speed here. That's what we're going to use, speed. Let's click on this plus button and add motion field, and let's click on this circle and look for our idle animation. Then click on this plus button again, add motion field, then look for our walk animation. This is it down here, walk. Okay, now what's going to happen is, let's run this preview. Here we have the character in the idle state. If we increase the speed, the character will start slowly walking until the speed reaches 1 and the character will be fully walking. And then when the speed reaches 0, our character will come back to the idle animation. Here we have automated thresholds, but we can edit this. But since we have 2 animations, it doesn't matter that much. We can keep the threshold automated. Basically, what the threshold means is at which point, here we have the threshold set to 1 by default. Maybe we want the animation to have a maximum speed of 3 or 4. For example, if you have a maximum speed of 4, if we set the threshold to 4 here, if we are at 2, the character will be in between the idle and walk animation. Like I said, for 2 animations, it doesn't really matter. Now it's going to matter if you have a more complex character that has walking backward animations, running, strafing animations. In that case, yeah, it makes sense to fine-tune this threshold, but for our purposes today, it doesn't really matter. Okay, let's go back to the base layer. Now we need to set these transitions with the movement state as well. and we need this movement state to be the first state that the character starts in, and we're going to delete this idle state. So let's right click on movement, set as layer default state, and here you can see that this entry node is pointing to our movement instead of idle. And now we need to make the same transitions here, but let's actually think a little bit smarter here. We need to transition to jump and fall from basically any state. So in this case, let's use our any state node here. This represents any state in the animator. And by the way, this animation system in Unity is called mechanism. Okay, let's transition from any state to jump. Let's make a transition. Now the condition will be that jumping is true, and here, since we're using any state, this any state could stand for the jump state itself, and we don't want that. We don't want jump to transition to itself. So in the transition, we're going to unfold these settings here, then go and uncheck can transition to self. That way we don't have these issues, and you can try it yourself. Your jumping state will exit and enter itself over and over again. Okay, so here it's safe to remove this idle state, but we still need a transition from fall to movement. For this transition, let's uncheck has exit time, and let's add the condition that fall is true, and let's save. Okay, now we have a more organized animator, and now we need to provide the animator with this speed variable. Let's go to our script and let's right click on player, edit script. Now in the update animator method, we need to set the speed on animator. So we're going to say animator.set float, since the speed is a float, and we're going to type speed here, and we're going to need to give it a speed. Let's compute the speed of the character controller. Now if we say character controller dot velocity, this is a vector tree that represents the velocity of our character controller, and in order to get the speed, we can say dot magnitude, and this will give us the speed. However, it will also contain the speed along the y-axis. What we can do is eliminate that speed. Let's say vector 3, let's call it velocity, or let's call it horizontal velocity. It's the velocity of the character controller without taking into account the y-axis. Let's set it to character controller dot velocity, and we're going to say horizontal velocity dot y equals 0, and the speed, let's define a float here, speed will be equal to horizontal velocity dot magnitude. Now let's set the speed parameter on our animator to speed, and this should do it. Now before we run the game, we still have our character up here, so let's bring it down to the ground level, and let's rotate it to make it face the camera. If we hold Control while rotating, we can snap the angle, or we can activate grid snapping. Holding Control is a quick way to do it. Okay, let's run. Now we're going to move, and you will notice that our code is working. Our script is properly getting the speed and setting it on our animator, and this is enough to make this work. However, I don't like that the character turns instantaneously. Let's fix that. Let's go back to our player script. We are changing the rotation of the character in this method, update player rotation, and we're setting the angle on transform instantaneously. We want to set this rotation to this value, but slowly over time. Let's comment this line out. What we can do is use some useful methods in Quaternion. We have this method, rotate towards. It takes a quaternion, which is the source rotation, the starting rotation, and then you give it the target rotation, and then you give it the max degree delta. If we use it like this, rotate towards, and the starting rotation is going to be our transform dot rotation, and the goal or the target rotation will be this. Why don't we just create a variable here, quaternion target rotation, and we're going to assign it this value, quaternion Euler player rotation. This is our target rotation. In here we're going to say target rotation, and we need to give it a max degrees delta. Let's define it here as well, float max degrees delta, Let's use a speed variable. We need a speed variable, for example, 60f multiplied by delta time. And we're going to use it here. Let's add a semicolon to the end, and we're going to assign this value to our transform.rotation. So instead of doing it instantaneously, we're going to do it slowly over time. And for this, perhaps we can use a variable that we define at the top of the class and that we can modify in the inspector. Let's call it turn speed, and let's go up. Let's define it here. Serialize field, private float, turn speed. This is going to be in degrees per second. Perhaps we can set it by default to 120, but we can edit it in the inspector and test different values. Okay, let's go back to Unity, and on our player script, here we have our turn speed. We're going to run the game and test. Perhaps it's too slow. The character takes a long time to turn, but at least it's smooth. It's better than what we had before. If you want a floating inspector, you can right click on player, then click on properties, and this will create this floating inspector. And now even if we maximize the game, we can still have this inspector here and we can change the values. So for turning speed, let's set it to 360. Okay. This is much better, but a little slow. Let's set it to 500. Okay, this is way, way better. I think I'm going to keep it this way. And perhaps for the walking speed, let's set it to 2.5. Okay, this is good. Let's right click here, copy component, then go out of play mode. Then on this same inspector, let's paste component values. These are the values that, for my test at least, they look and feel good, but if you want to change them, you are free to do so. Perhaps you want a more grounded, more slow game, or a more arcadey and faster game. It totally depends on you. In this lecture, we're going to add some components to animate the camera. Right now, our character can move around, but the camera is not following. We could write a script ourselves, and I encourage you to do it. It's a good exercise for applying everything that we've seen so far. You can add a script to your main camera with a reference to a target, and this target you would set it to the player, and this script will maintain the camera at a certain distance from the player and also at a certain angle. And on transform we have a useful method called look at. You can use this to make the camera look at the player at all times. However, making a camera controller yourself is quite difficult because it's not just about doing the basics, it's about creating a smooth controller and handling a lot of edge cases. We're not going to write a script to control the camera. I'll let you create your own camera script as an exercise, but what we're actually going to use is the Cinemachine package. With Cinemachine, you can implement a lot of different cameras for your game, and it's packed with features. If you want camera shake, if you want to switch between multiple cameras, it has a lot of behaviors that you can use. So it makes sense to use this pre-made package rather than make your own script. We have to install Cinemachine. Let's go to Window, Package Management, then Package Manager. In my project, I can see that I don't have Cinemachine. It's not installed by default. Let's go to the Unity registry and let's look here for Cinemachine. This is it. Let's install it. I encourage you to look for the Cinemachine documentation and also read through the Unity manual. Here in the documentation, you have a detailed explanation on how to use the package and how to achieve various results. It's always a good idea to read the official documentation. Okay, Cinemachine has been installed. Make sure it's version 3 because there is a big difference between version 2 and version 3 of Cinemachine. Now let's click on our main camera. We're going to add a new component here. Let's click on add component and we can either look for it or we can go here to scene machine and we need to add a scene machine brain to our main camera. Okay, now we have a few parameters here. I'm going to uncheck show camera first term because this could get annoying. If you keep it checked, even if you deselect the camera, you'll get this camera shape, camera first term shape. I prefer to keep it unchecked, but for the rest, you can leave it as it is. Now for the actual camera, let's click here on this plus button, then go to Scene Machine, then Scene Machine Camera. The idea that Scene Machine uses is that we don't create multiple cameras. We have one main camera with one Scene Machine brain, and then you can have multiple of these Scene Machine cameras. They're just empty objects with the Scene Machine camera script. They're not actual Unity cameras, but you can have multiple of these and you can switch between them. Once you get the hang of it, it's a really neat system. Now we need a tracking target on our camera. Let's set it to the player. We're going to drag and drop the player to the tracking target field. Now we can edit the lens. Here we can edit the vertical FOV. Let's add some procedural components. For position control, we have a drop down here. We can choose from a lot of behaviors. Let's choose follow. Now the camera will follow our player. We can choose a follow offset. We can preview it in the game view. Let's set the follow offset to something that would put the camera in the top-down view. Let's set the Y to 10, for example, and Z to -10. And here we need the camera to look at the player. For this, let's add a rotation control. Let's choose hard look at. This is a simple component which makes the camera simply look at the target. You'll notice that by choosing an option here, Scene Machine has automatically added more components. Now let's change the vertical FOV. Let's choose a value of 25 and perhaps we can have the camera be a little bit farther from the player. For this, let's set the follow offset on Scene Machine follow to 0, 12.5, -12.5. Let's run the game and see our camera in action. I'm going to maximize the game view. This is how our camera looks like. You can see that there is a slight delay when we move the camera. We can fix this by setting position damping to 0. Let's set it to 0 on all axes. Now the camera is locked on our character. All right, this looks good. The camera is able to track our character. Now to save the data in the inspectors of our Scene Machine camera, we can check save during play. And by going out of play mode, we'll get this dialog, save changes made in play mode. We can choose to keep the changes. Let's put our Scene Machine camera at the top and let's rename it to top-down camera. In this lecture, we added a Scene Machine camera to our scene and we made it follow the player around. Scene Machine is a quick way to add a camera to your game. It's packed with features. I highly encourage you to go to the documentation and read all about the different features and the different elements that you can use in your game. It's much faster than writing your own camera controller, but that could be a good training exercise, so I also encourage you to try and do that.